With paper 1 out the way, it's time to turn our attention to paper 2. So today's video covers my top 4 tips for GCSE Maths paper 2 revision. Tip 1, my paper 2 revision checklist. Using the link in the description, go to my website and download my paper 2 revision checklist to identify the topics that you need to prioritise. Then work through those specific video lessons available for free on my YouTube channel. Tip 2, my paper 2 practice booklets. Once you've worked through the YouTube lessons identified by the revision checklist, then you need to work through my paper 2 specific practice booklet to solidify your understanding of the topics in preparation for the exam. Tip 3, my paper 2 practice papers. The night before the exam, it's time to complete my paper 2 practice paper to refresh your understanding of the topics that I'm guesstimating will appear on paper 2. Tip 4, my rapid revision system. Alternatively, if paper 1 didn't go as well as you were hoping, or you just need a time-efficient solution due to the other subjects that you need to revise for, then you should sign up for my rapid revision program upgrade, as it combines all the benefits of the previous points but turns them into a personalised revision plan for paper 2, which means that all you need to do is complete my paper 2 revision quiz and you'll know exactly which lessons or topics you need to work on to maximise your maths in minimum time. This is my paid programme, but if you sign up for 1 month now, then you'll get priority access to both my paper 2 and 3 specific revision resources. Sign up for a free trial of Upgrade today. Okay, so looking at our first question on using a calculator. Now with using a calculator, we just need to make sure it looks exactly the same. So here we've used our fraction button, we've then typed in the cube root, and we're using our blank power button, making sure we come out of the power here before pressing the tan button. We don't need to put that degree symbol in. So onto the bottom of the fraction, 9 to the power of a half. Once we've typed it in and we're happy it looks exactly the same as it does on the paper, we'll press equals. This question wants us to round to 3 significant figures, so we'll chop after the 1 here, so that'd be 0.482 as our final answer. So just making sure it looks identical to however it does on the page. When looking at the lowest common multiple, we can approach this question in one of 2 ways. We can either start by listing multiples of each number until we get that first matchup. So we could write 40, 80, 120, 160, 200. Typically I'd write at least 5 and then we'd move on to the other side. So now moving on to the 56s, we get 112 and then 168. And at some point you're going to see that of course we're going to go past that 200. So 224, add another 56 gets us 280, and this is going to match 240, 280, and we have our lowest common multiple. Now, if the numbers are slightly higher or a little bit more complicated and you think the list is going to go on for quite some time, you can write these numbers as a product of prime factors. So 40 would be 4 times 10, and then we have 2 times 2 and 2 times 5, and then we can go for the 56, which is 7 times 8, and then keep going with your 8. And there we go. So once we've got these as a product of prime factors, what we do is we have a look at our list and we match up what's in both. And you can write that out as a long list, or you can do it from your prime factor tree, but both of these have a 2, they both have another 2, and they both have another 2. So anything that's in both, we'll times those together. So 2 times 2 times 2, and then have a look at what's in the numbers on their own. We have a 5 and a 7, and then we just do times 5 times 7. I can type that in on the calculator. So 2 times 2 times 2 times 5 times 7, click equals, and we get the answer 280. So looking at some product rule for counting. It says here there are 95 girls and 87 boys. One girl is going to be chosen for the role of head girl, and a different girl is going to be chosen for the role of deputy head girl. And then we have the same options for the boys. It says work out how many different ways this can be done. Now with the product rule for counting, and the hint is in the title for this, product means to multiply. So all we have to do is find the different options in each scenario and we'll multiply them all together. So here we have one girl is going to be chosen, and that's out of 95 girls. Now a different girl is going to be chosen for head girl. So once the head girl's been chosen, the deputy head girl, there's only going to be 94 options. With the boys, there is 87 boys, and once the head boy has been chosen, there will only be 86 choices. Now if we wanted to find the combination of the different girls that could be chosen, we'd just do 95 times 94. However, for each of those different combinations of girls, there is then one head boy which is going to be chosen, which means we need to multiply that by 87, and then there's 86 boys that could be chosen for the deputy head boy. So all we have to do is multiply all of these together, 95 times 94 times 87 times 86. We are going to get a very large number here, but our final answer is 668,14260. There we go, that is 66,814,260 different options. Now in this question we are looking at some standard form. If we need to convert numbers in standard form, it might be that if you type it into the calculator, it'll do it for you. So this particular number here, it comes out as a fraction, so if we convert that, this one on my calculator does come out in standard form. If it doesn't, you just write the number down, hop that decimal so it's between 1 and 10, and this one has a negative power as it's a 0-point number. For the next part of this question, we have quite a large sort of fraction to type in under this square root. We need to put these numbers that are in standard form into the fraction, being careful to put our negative power in, and then coming out of the top onto the bottom, and this one has d cubed on the bottom. So I'm going to put this one in brackets, 1.4 times 10 to the negative 4, and then once I close the bracket and make sure we come out of the power, then I can put my cubed in, and there we go, we have our power of 3, pressing equals, and we will get our answer. It does want this to 3 significant figures, so we'll write that down, drop it after the third number, so that'd be 4,520, and then we need to hop the decimal back in 3 jumps to make it 4.52, and that'll be times 10 to the power of 3. Now on to some reciprocals and error intervals. Now when you're finding the reciprocal of anything, all you need to do is flip it over. However, if it's not already written as a fraction, then when we flip it over, we just imagine that it's sat over 1. So flipping that over would become 1 over 1.6. Now we can't leave that as a decimal within a fraction, and it does say to give your answer as a decimal. So if we just type that into a calculator, you can type it in as a fraction, or 1 divided by 1.6. It comes out, and on my calculator, it turns it into 5 over 8. I'll use my conversion button, and that turns it into 0.625, and there we go, that is our reciprocal of 1.6. For the next part here, we're looking at an error interval. It says that Jessica rounds a number, x, to 1 decimal place, and the result is 9.8. Write down the error interval for x. So when we are looking at error intervals, 9.8 to 1 decimal place is actually between the two numbers 9.7 and 9.9. When we're looking at error intervals, we want the cutoff points that's in between those two in order for it to round to 9.8. So in between 9.7 and 9.8 is 9.75, and in between 9.8 and 9.9 is 9.85. So that's our lower bound and our upper bound, which will go into our error interval. So on the left, we have 9.75, and on the right, we have 9.85. And there we go, there's some error intervals. Now, when looking at bounds, we do have a lot to type into a calculator. It's not overly complex to type this into the calculator, it's just getting those error intervals correct and using the correct bounds. So, when typing this into a calculator, it does look very similar to a previous question, so we won't use a calculator, well, we will use a calculator, but not on the screen for this one, as it's relatively nice to type in. So here, we have E is 6.8, correct to 1 decimal place, and using error intervals for that, E is therefore going to be between 6.85, adding that 5 on the end, and 6.75, and just dropping that down by 1 for the 8, and then sticking the 5 after it as well. For 0.05, not as nice actually to write the error interval for, but that's going to be 0.055 and 0.045. And there we go, there are our error intervals. It says here to work out the upper bound for the value of p. So to get the upper bound, which is the biggest possible answer, we want to have the biggest possible answer here on the top divided by the smallest on the bottom. So this will be the upper bound on the top and the lower bound on the bottom. So E, we want to use our biggest possible number. So for E, we're going to use 6.85. And for F, we want the smallest possible answer, so 0.045. So all we need to do is type that into our calculator. So we're going to do the square root of 2 times 6.85, and on the bottom we're going to do 0.045. Once we've typed that in, it does want us to give our answer to 3 significant figures, but if we type that into the calculator, 2 times 6.85 on the top and 0.045 on the bottom, making sure it's all underneath the square root, we get a final answer which comes out as 17.4483344. I've written the whole number down. Now I'm going to round it to 3 significant figures, which is just after the 4 there. So that comes out as 17.4, and that is our upper bound. Now again, if we were asked to work out the lower bound here, then you would put the smaller number, or the smaller or the lower bound of E on the top, and the upper bound of F on the bottom. If we were asked to consider bounds, then we'd actually work both of them out and see if they round the same. So just read the language very carefully in these questions. But there we go. This one just wanted us to find the upper bound. Okay, so looking at some expanding and factorising. Now here we have 2 sets of single brackets to expand. We just need to be really careful on this one as we have got a subtraction there in the middle. So for the first bracket, we have a nice expansion, just multiplying those by 5. So that'd be 5p plus, and then we have 15. Now for the second bracket, there are 2 ways to approach this. We can either multiply everything in the bracket by 2, and then remember to subtract them, which just means we have to think a little bit more carefully, as there is a negative 2p there. And when we're subtracting a negative, it will turn into a positive. So you just need to be really careful. Now I prefer to just multiply by negative 2 straight away. Then I don't have to think about that process later on. So negative 2 times 1 is minus 2, and negative 2 times negative 2p would be positive 4p. And now we can collect those like terms together. So we have 5p, add 4p, so in total we are going to have 9p. And then we also have the 15 here, take away 2, which leaves us with 13, so that's plus 13 in total. And there we go, we get 9p plus 13. Now this next part here is a little bit of a strange quadratic. We have a squared minus b squared. We're being asked to factorise that. Now this is very similar to a difference of 2 squares, a normal quadratic that we would see, something like x squared minus 16. And hopefully if you saw that one, you would know that that is x plus 4 and x minus 4 in the brackets. Now this is exactly the same above. It's a difference of 2 squares. It's just a squared and b squared. So we'll factorise this in the same way. We'll have a plus b and a minus b. And there we go, that's factorised. And if you were to expand that, you get a squared, then you get minus ab plus ab, and they cancel each other out, and then the minus b squared. It says hence or otherwise, simplify fully, and then it's given us basically the same thing, except there's loads of pieces in the bracket. Now this here, we have this x squared plus 4, that's just our a. And then we have this x squared minus 2, and that would be our b. So all we need to do is replace the a's and b's in our previous answer, the a plus b, a minus b, with these new pieces. So if we start with the a plus b, well, a is x squared plus 4, so x squared plus 4, and then we're adding b to that, so adding x squared minus 2, and that's our first bracket done. And in the second bracket, it's a minus b, so x squared plus 4, and here's where you've got to be really careful because we are subtracting b, so minus the x squared, and then we're going to subtract the negative 2. So we're looking at this piece here now, this subtraction of that negative 2, and that would be plus 2. So if we simplify what we have in the brackets, on the left bracket, we have 2x squared, 4 and minus 2 makes plus 2, and that's our first bracket. The second bracket, if we simplify what's in there, we have x squared minus x squared, so that's gone completely. and then the 4 plus 2, which just leaves us with 6. Now normally if we had something written like that, of course we would write that as a single bracket, 6 lots of 2x squared plus 2. And we do want to simplify this. There's two things we could do. We could either expand that, which would give us 12x squared plus 12, or we could go ahead and refactorise it and fully factorise it, in which case we could put 12 on the outside and you could have x squared plus 1 on the inside. Now either one of those answers would be fine. I would probably just leave my answer as 12x squared plus 12. It doesn't say it needs to be given factorised, it just says it needs to be simplified. But there we go, there's some expanding and factorising. Okay, so on to some algebraic fractions. Now in this one we are dividing algebraic fractions. When we are dividing algebraic fractions, we just need to multiply by the reciprocal. So keeping the first one as it is, flipping the second one over, we're going to times them instead. It does say it can be written in a particular form, so we need to be aware of that and just be really careful as we go. But let's have a look at the first fraction. Now the first fraction just has 6x cubed on the top, so that can stay as it is. The denominator here does have a difference of 2 squares. So 9x squared minus 144, 9 and 144 are both square numbers, so that would factorise to 3x plus 12 and 3x minus 12. There we go, just the square root of 9 and the square root of 144 in those sort of replicated brackets where one's a plus and one's a minus. Now it's up to you, we can factorise the second one if it needs factorising. This particular one doesn't look like it actually needs factorising, so we can just flip this over and start to get to a point where we can start to think about multiplying them. So we have 2x to the power of 4 on the bottom and 3 lots of x minus 4 on the top. Now from this point we are kind of looking now to see if anything can actually factorise or cancel off or anything at all. So at the moment you can see that there is a 2x to the power of 4 on the bottom right and a 6x to the power of 3 on the top left. Now we can actually divide both of those by 2 and both of those by the x to the power of 3. So we can cancel those down. If you want to write that in one step, we could say, well, divide the top here by 2x to the power of 3, and we'll divide the bottom here by 2x to the power of 3. Now looking at the bottom left fraction of the fraction and the top right of the right fraction, there's nothing actually at the moment that simplifies there. However, if we expand this bracket, we get 3x minus 12, and that does match one of the brackets on the bottom left on the left fraction. So they're going to cancel off as well. So actually we can divide by 3x minus 12. That's going to cancel off this numerator here. When we divide by 3x minus 12, as there's only 3x minus 12 there, that will just turn into 1. And this 3x minus 12 here will disappear. So that's all the kind of thought process as to what we can cancel off to start with. So we need to write what we've actually got left once we do that. And we'll still keep it as two fractions for the moment. So here, 6x to the power of 3 divided by 2x to the power of 3, well that fits in 3 times. So we have 3 as our numerator. On the bottom, we just have that 3x plus 12 as the 3x minus 12 has now cancelled off. We don't need to keep it in brackets anymore because there's nothing else with it. We're going to multiply that, and on the right fraction we have 1 on the top as we've cancelled off that 3x minus 12, and on the bottom we have 2x to the power of 4 divided by 2x to the power of 3. Well, that just is x, as it's x that you have to times by 2x cubed to get to 2x to the power of 4. So that's what we're left with. We now just need to expand this, or expand the brackets on the top and the bottom. Now on the numerator, it's 1 times 3, so no bracket there, just 3. On the denominator, it's x multiplied by 3x plus 12. So that will give us 3x squared plus 12x. Now we're kind of getting there, but this does want it in a particular form. It wants it to be 1 on the top. Now if it wants it to be 1 on the top, that means that the numerator and denominator must divide by 3. And you can see that that denominator does factorise by 3. So we could factorise the bottom by 3, so we can cancel these 3's off, and that would leave us with x squared plus 4x. Now we can actually cancel off the 3's. We will get 1 on the top now when we divide by 3. So if we rewrite that, let's see what it looks like. We have 1 on the top, and we have this x squared plus 4x on the bottom. Now we are almost finished. It does say in the question it wants it in the form on the denominator here, x brackets x plus r. So we just need to factorise x out of the denominator. We've still got 1 on the top, which is what we wanted. On the bottom we'll have x lots of, x times x makes the x squared, and x times 4 makes the 4x. And there we go. R, or the value of r, is 4, and we've got it in that form that it was asking for. There you go, quite a complex algebraic fraction there, but lots of steps in terms of how to cancel or cross-cancelling in the start, and also cancelling by factorising. And this was quite an interesting one because we actually had to expand the numerator on that right fraction in order to cancel off those common factors. So there we go, a nice interesting algebraic fraction question. For this next algebraic fraction, we are adding or subtracting. In this particular one, we are actually subtracting here. It says show that, and then we have a big calculation to work out. But it says show that it can be written in the form ax plus b over x squared minus 4, where a and b are integers. Now when we are adding and subtracting, the same as just with normal numbers, we do that from left to right. So here we're going to first subtract these two fractions, and then we will deal with that subtraction of 1. So let's just start by doing those. Now we need a common denominator in order to subtract these. So that means we need to multiply this left fraction by x minus 2 and this right one by x plus 2, and that's on the top and the bottom. So if we write that out in sort of a long form, we have 3x multiplied by x minus 2 on my numerator, and that's now over x plus 2 and x minus 2. On the next fraction, we have 2x plus 1 multiplied by the x plus 2, and that's all over the same denominator, x plus 2 and x minus 2. And there we go. So let's just look at expanding these and sort of tidying it all up and just seeing what it looks like, and then we'll think about that one. So for this first fraction, 3x times x and 3x times minus 2. 3x times x is 3x squared, and 3x times minus 2 is minus 6x. The denominator, x plus 2 and x minus 2, we can expand that because it does want it in an expanded form. It says here x squared minus 4, and actually that is a difference of 2 squares anyway, so it does just become x squared minus 4. You can take your time to expand that if you want, but you'll see those two middle pieces cancel out. We need to subtract from that then. Our next one, we already have the denominator, so we can write the x squared minus 4 on the bottom. We just need to expand these double brackets. So 2x times x gives us 2x squared. And to save myself actually too much working out here, I'd probably expand this just to the side so that I can tidy it up and put it straight on the numerator, so I don't have to keep writing this out. So we've got the 2x squared. 2x times 2 is going to be 4x. Then 1 times x plus 1x. And 1 times 2 is plus 2. So we just want to join these middle pieces together. That'll be 5x, so we can write that on the numerator now, plus 5x plus 2. Now we do have to subtract these fractions, so I need to be really careful, because when I subtract the 2x squared, I'm going to be taking that away. I'm going to be subtracting the positive 5x. I'm going to be subtracting the 2. Looking at this numerator up here and being really careful with that. So we have 3x squared on the numerator, take away 2x squared. That leaves us with x squared. We have negative 6x, take away 5x, that's minus 11x. And then we have nothing, take away 2, so minus 2. And that's all over x squared minus 4. So that is the first two fractions combined. We've already done an awful lot of work just to get to this point. But now I need to take away 1. Now with a whole number, I want to write that as a fraction. So I'm going to write that as minus 1 over 1, which seems a little bit strange to do, but we need a common denominator. Now our common denominator that we're going to need is x squared minus 4. So I'm going to multiply both sides, well, top and bottom, by x squared minus 4. As it is just 1, it is actually relatively nice. They both just come out as x squared minus 4. So if I write that out so I can deal with this subtraction, on the left we have x squared minus 11x minus 2 all over x squared minus 4, and the right fraction is going to be x squared minus 4 over x squared minus 4. And again, being really careful here because we do have that subtraction again. So when we subtract these, we are going to just need to be really, really careful with those positive and negative symbols. Let's just move this out of the way so we have some space. So what do we get? Well, x squared, take away the x squared. So just looking at these two to start with, they actually cancel out. So they're gone completely. So we have minus 11x, take away, and there's no x's there, so that'll be minus 11x. We have minus 2, take away minus 4. So when we take away negative 4, that's going to add 4. We're starting on negative 2. Again, you can use a calculator for this, but that's going to become plus 2. And then on the denominator, we have x squared minus 4. And there we go, we've joined it all up. Now, normally I would write that as 2 take away 11x on the numerator, but it wants it in the form ax plus b, so we'll leave it in that form there, minus 11x plus 2 all over x squared minus 4. Obviously a very large question there, lots to think about, lots of positives and negatives to be careful of. You can always use your calculator at any point for those positives and negatives, of course, if you're doing a calculator paper. But there we go, there was some adding or subtracting algebraic fractions. So with these styles of negative or fractional indices, when they are in reverse, we need to be very aware of the rules and how indices are used. So in this one here, we have a fractional indice involved, and it says ax to the power 9, and that's all to the power of 1 over n is equal to 3x to the power of 3. So it says work out the value of a and the value of n. So in this case, with a fractional indice, we're going to need to have a look at which pieces we've been given and how we might get there. So we have been given that there is a power of 9 and it's turning into a power of 3. So we need to think about this 1 over n and how we're going to get from 9 to 3. Now powers in brackets multiply. So this power, 9 to the power 1 over n, would be multiplied. And that would give us 9 over n. And that's going to equal 3. So in this case, n must be equal to 3, as that's what you divide 9 by to get to 3. So we've got our first one, so we know that that is now to the power of 1 over 3. Now we need to think about the a. How are we going to get from a to 3? Now, a power of 1/3 does a cube root. So a to the power of 1/3 is going to be equal to 3. And that's almost a reverse root. So we're thinking what number cube rooted is going to equal 3? Well, to reverse that, if we write it as the cube root of a is equal to 3, well, we would have to cube both sides to get rid of that cube root. So a would be equal to 3 cubed, and 3 cubed is equal to 27. So a must be equal to 27. Now, if you're not 100% sure, of course, you've got to know these power rules very well, your laws of indices, but now we would have 27 x to the power of 9, all to the power of 1/3. Now, working forwards with this question, we would do the cube root of 27, which is 3. And the power of x we would times by 1/3. So x to the power of 9 times 1/3. And that would give us x to the power of 3. And that's exactly what was given to us in the question. So there we go. For this question, a was equal to 27 and n is equal to 3. So we've got some changing the subject here where we have roots and powers involved. It says here to make k the subject of the formula. Now, if everything is underneath a square root or a cube root, the first thing we need to do is to unlock what's underneath by getting rid of the root. The way to get rid of a square root is to square both sides. So the first step is relatively nice because if we square both sides, well, the left side would become m squared, and the right side here, we were just getting rid of that square root. So we're just going to write what's underneath it, k cubed plus 1 all over 4. We now have a fraction, which is stopping us from moving pieces on the numerator. So to get rid of the fraction, we're going to need to multiply by 4, as that obviously means dividing by 4 on the bottom. That's going to remove this divide by 4. And then on the left, we will have 4m squared now. And that's now equal to k cubed plus 1. Now at this point, you've got two options. We could cube root, however I do like to do the powers last there, as normally you do powers first when you're going forwards, but we are doing the inverse. But you just need to remember you'd have to cube root everything. So instead of doing that and forgetting to cube root things, I'm going to subtract this 1, and that will leave me with 4m squared minus 1 is equal to k cubed. We can now think about removing that cube by cube rooting both sides. If we cube root the left now, we get the cube root of 4m squared minus 1, and that is now equal to k. And you can write that the other way around if you want. You can write k is equal to, and it might say k equals on your dotted line, k equals the cube root of 4m squared minus 1. And on to some changing the subject with factorising. So it doesn't tell us in the question we're going to need to factorise, but the big hint that we've got a more difficult version here is the fact that there is an a in two places, and that's what it wants us to make the subject. So we have an a here and an a there. So it's not sufficient just to minus the 3 and then have it as a equals because there's another a on the other side of the equal sign. So we need to get all the a's on the same side. To do that, we're going to need to unlock the right-hand side by multiplying by r. So the first thing I'm going to do is multiply by r, and that's going to give us AR plus 3r on the left-hand side. We'll then just have this 2a plus 7 on the right. Now we want the a's on the same side of this equal sign, so it's up to you. You can either move them to the left, or you can put all the a's on the right. I tend to prefer to move them to the left, but always just look at the symbols and see if it's going to create any additional negatives anywhere, or if we can remove negatives by moving to the other side. Now in this case, we have plus symbols on both sides, so it doesn't really matter, so I'm going to minus 2a to the other side. Now we also need to minus 3r. You can do that in one jump if you're happy doing so, but I'm going to move it in two steps. So I'm going to do AR minus 2a, and then we have the plus 3r, and that's equal to 7. Now I'm going to minus this 3r, so we have the a's on their own, and that's going to make it AR minus 2a is equal to 7 minus 3r. And of course this would look slightly different if we move the a's to the right. Now at this point we can factorise the left. We can factorise the a out of the bracket, which will leave us with r minus 2 inside the bracket, and then we have that is equal to 7 minus 3r. At this point the final step is to divide by this bracket. That's going to isolate the a and leave it as a equals, and then as we are dividing by that whole bracket, we need to create a fraction. So we have 7 minus 3r all over, and it's up to you at this point. You can leave it in the bracket or you can remove the bracket, but we have r minus 2, and there we go, and that would be our final answer. A is now the subject, and a does not appear anywhere else within this. So there we go, that is changing the subject with some factorising. Now for our next question, we are looking at completing the square. And it doesn't say here to complete the square, but it says write it in this form. And this is completed square form, and it tells us a and b are integers, so whole numbers. So when doing this, we need to halve the coefficient of x, and that's the number that goes into our bracket. So when we write it in this form, straight away we get the x plus 3 in brackets squared. And again, we've got the 3 there, but just by dividing the 6 by 2. Now there are different ways to approach completing the square. I just look at this number in the bracket and think, well, if I was to expand this bracket, bearing in mind it's a double bracket, what number would we get at the end? And if I expand that, I would get plus 9. Now in our quadratic that we have, we want minus 7. So if we want minus 7, then to get from 9 to minus 7, we just need to figure out what that jump would be to complete this square bracket. So to get from 9 to negative 7, you can always do that on the calculator, but that is a jump of 16. So we would have to subtract 16, and there we go, it's now written in completed square form. Don't be put off by the fact that in the question it said plus b here. That's absolutely fine. Our B is just negative 16. If you're asked to find turning points from this, remember that the turning points are the numbers that are shown in completed square form. The only thing that you need to watch out for, the x coordinate, is that number in the bracket, but you have to flip the symbol, so it'd be -3 and -16 for the turning point if we were asked to find it, but of course this question was just asking us to write it in completed square form. Okay, so with harder completing the square, we tend to have these coefficients of x squared greater than 1. Now this particular one is actually even more challenging, as we have a negative coefficient of x squared as well. Now typically when they are written as a negative, that x squared part will be at the end of the quadratic. Now I like to personally rearrange it so it's back into the order that we used to seeing a quadratic in. So I'm just going to rearrange these so that the x is in the middle and that +9 is at the end. Now when we are factorising a harder quadratic, we have to factorise out the coefficient of x squared when we are completing the square. So here we would take -3 out of the quadratic, which means everything's going to divide by -3. So we would get positive x squared. 18 divided by 3 would give us -6x. And 9 divided by -3 will give us -3. So you can see there that the symbols have also changed in front of each piece. From here we can complete the square by halving the coefficients in front of x. So we get x -3 squared. Now when that's expanded, it would give us +9. Now we want -3, so we would have to subtract 12. Now we've completed the square for what's inside the bracket, we have to reintroduce this -3. So everything is going to get multiplied by -3. Now rather than writing another curved bracket, I'm going to put this outside of a squared bracket, just so we can differentiate between those different types of brackets. What I now do is just times everything by -3. Now the nice thing is, the bracket at the start, the -3 can just go in front of that. So it's -3 lots of this x -3 squared. The -12 at the end, being a number, is going to get multiplied by -3, which would give us +36. So we now have it in completed square form. We just need to be able to read the turning point. So the x coordinate, as always, is just the flipped version of what's in the bracket, so +3. And the y coordinate, as always, is just this number at the end, +36. So there we go, that is completing the square where we have these harder coefficients of x squared, and this one even had the negative in, making it that little bit harder again. Okay, so for a simultaneous equation, there are lots of different ways that you can approach this. The way that I approach it is I make the coefficients of y the same number. Not necessarily the same symbol, but just the same number. So here I'm going to look for the lowest common multiple of 6 and 4. So for me that would be 12, so let's times by 2 and times by 3. We'll then have a +12 and a -12. So timesing the top by 2, we get 4x plus 12y is equal to 10. For the bottom one, we get 9x minus 12y is equal to -36. Now the way that I approach these is if these have the same signs, I subtract the equations, otherwise we add them together. So we're going to add these two equations together, and that leaves us with 13x is equal to, and 10 take away 36, because we're adding -36, gives me -26. Now that's good, because 13 does go into 26, don't forget it's negative there, so x is equal to -2. And of course you can get decimals in this part of the equation too, and if you have a calculator, of course you can just type that in and get your nice decimal solution. Now we have the value of x, we need to substitute it into one of the equations to find the value of y. Typically, I'll always pick the one that has a plus symbol in, so I'll go for this top one. So we have 2 times -2, which is -4. So our equation is -4 plus 6y is equal to 5. To solve this, we can add 4 to both sides, getting rid of that -4, and that gives us 6y is equal to 9. And now we can divide by 6, and that gives us y is equal to, and I could either write that as 9 over 6, or if I'm not sure, I can just type it into my calculator, and 9 divided by 6 is 1.5. So y is equal to 1.5. So there we go, we get two solutions, one for x and one for y, and that's our simultaneous equation solved. Okay, so looking at solving quadratics using the quadratic formula. Now when you're on a calculator paper, even if a quadratic does factorise, it doesn't mean that we can't use the quadratic formula. So here the first thing we want to do is we want to label the values of a, b and c. So a is 6, b is 5 and c is negative 6. We can write down the quadratic formula and start typing it into our calculator. So I tend to start by starting with the plus symbol, doesn't actually matter, but we'll start with the plus symbol here and putting that b value in brackets. So we have 5 squared here. We're going to take away 4 lots of a, which is 6, and c, which is negative 6. And then on the bottom we have 2 times a, so 2 times 6 on the bottom. We can press equals and we'll get our first solution here. We can write that down as a fraction, or we can convert it into a decimal. Just be careful, this one is recurring. And then we can start looking at the negative version. So we want to go back into our calculator rather than typing it all in again, and just go all the way back to that plus symbol. We're going to delete the plus symbol, put in that subtraction, and then press equals again. We get our second solution there, which is negative 3 over 2. Or of course, you can write that as a decimal. And there we go, that's the quadratic formula. Okay, so in this question we have a quadratic simultaneous equation. We do have quite an extensive one in this particular question. So we're going to use the substitution method, but you can see our second equation there, we have a 3x and a 4y. So we want to rearrange that formula so it's either x equals or y equals, which does mean we're going to have fractions involved in this one. Now it's better here, I think personally, to make it x equals, and that's purely because we have a 1x squared here, and that's just going to avoid multiplying it by 4 as well once we've sort of squared it and subbed it in, but it doesn't actually matter either way. Now I'm just going to opt for making it x equals. So I'm going to rearrange this formula to start with so that we have our x equals formula. So to do that I need to minus the 4y, so we have 3x will be equal to 7 minus 4y, and then divide by 3, we get x is equal to 7 minus 4y, all divided by 3. I can now substitute that into that first equation. However, it is x squared, so we need to work out what that is squared. So x squared is first going to be equal to 7 minus 4y all over 3 squared. Now that means we're going to have a double bracket on the numerator. The denominator is nice and easy, 3 times 3 is 9, but I do have a double bracket I need to expand. So I need to get that out of the way first, just to avoid huge amounts of working out written over and over again. So if we expand this double bracket, we have 7 times 7, which is 49, 7 times negative 4y, which is minus 28y, we get minus 28y again, and then plus 16y squared. Now if I just reorder that and write it into a normal quadratic format, we have 16y squared minus 56y plus 49. And there we go, there's our numerator. Now on the bottom, 3 times 3 is 9, but we can put that now all into this first equation. So we have 16y squared minus 56y plus 49 all over 9, and then we have minus 4y squared is equal to 9. Now in order to get this equal to 0 and into a format that we are used to, we do need to get rid of this fraction, so I need to times by 9, which will get rid of this divide by 9. I just need to remember as well, this is also multiplied by 9, and so is this number at the end. So I need to multiply everything by 9 essentially. Now when we do that, we have 16y squared minus 56y plus 49. The fraction is now gone. And we have minus 36y squared in place of that 4y squared. And 9 times 9 is equal to 81. Now I want this to equal 0. It now does only have y's in it. I can definitely solve it. I need to minus 81 and I need to combine these y squareds. 16y squared take away 36y squared would give me minus 20y squared. So I've got minus 56y, and then I need to do 49 take away 81. Of course we can just do this on the calculator. That gives me minus 32, and that's now equal to 0, and it can be solved. Now at this point, I can just write down the values of a, b and c and put it into the quadratic formula. However, I can see that these numbers divide by 4, so just to make the numbers a little bit nicer, I'm going to divide them all by 4, and that gives me minus 5y squared minus 14y. Again, you can just type this in on the calculator, and then minus 8 is equal to 0. I do just have some slightly nicer values of a, b and c now to use in the quadratic formula. So a is equal to negative 5, b is equal to negative 14, and c is equal to negative 8. I need to remember my quadratic formula, but now I just need to put the values in the correct place and just being careful as we type them in. And obviously we just looked at the quadratic formula, so we won't pop the calculator up for this one. We have minus b is negative, so that'd be 14, plus and minus the square root of, we've got negative 14, so making sure that's in a bracket, squared, minus 4 times negative 5 times negative 8. There we go, we'll have to extend our square root there. And that's all over 2a. A is negative 5, so 2 times negative 5. Now I need to type that in once using the plus symbol, and if we type that in for the positive, and I just like to label that the fact that I've used the plus sign. When we use the plus sign, we get y is equal to negative 2. And when I use the negative symbol, so go back into the calculator, delete the plus, put in a minus, we get y is equal to negative either 4/5 or 0.8. I'm going to leave it as a decimal, so y is equal to negative 0.8. So there's our two y values. I now just need to find the x values. Now I've got 2 that I need to find, and our equation for x is up here. So to get x, it's 7 take away 4y, all divided by 3. Now again, I'm just going to be typing this in the calculator, so we'll start with the negative 2. So we'll have x will be equal to, let's have a look, x is going to equal 7 take away, it's 4y, so 4 times negative 2, all over 3. And in that circumstance there, we get x is equal to 5. And for the next one, we have x is equal to 7 take away 4 lots of negative 0.8. Again, all divided by 3. And that gives us x is equal to either a fraction 17 over 5, you could write it as a mixed number as well, or the decimal is 3.4. So there we go, we have lots of numbers that we need to write down as our solutions. We have y is equal to negative 2, and in that scenario, x was equal to 5. And we also have y is equal to negative 0.8, and in that scenario, x was equal to 3.4. So a very complex quadratic simultaneous equation. Even just looking at all that writing, there is a huge amount there, so it's really important to keep this incredibly neat and tidy and ordered when you are doing this on the page. But there you go, there is a pretty tricky quadratic simultaneous equation. So with identifying types of graphs, there isn't really an approach that you can use to work this out, so to say, but you need to just recognise what these types of graphs actually look like. So question or graph A here, that is an x squared graph. You have a positive and a negative variation of your x squared graph. This one, it makes this U shape. A negative x squared is upside down. It makes this almost N shape. So recognising those is your starting point. You then have to look at your cubic graphs. So cubic graphs are these ones here, where we have this almost wiggle in the graph, and there's another one just there. So both of these are cubic graphs. Now the x cubed graph on its own only has one root. It passes through 0. So this one down here is the x cubed graph. The one in graph B just has some additional things along with the x cubed. But it still starts with x cubed. However, this one that we're given here, y is equal to x cubed, is graph F. Moving on to some other graphs, graph E is a straight line graph. So this would be y equals, and then maybe something like x plus, and then let's just make up a number, something like x plus 3, if the y-intercept here was 3. Of course, you can have a graph that's sloping downwards as well, and that would have a negative x value in terms of its gradient. The only two that are left over are our reciprocal graphs. So we have graph C and graph D. Now the 1 over x is a reciprocal graph. Now when we have part of the curve in this positive quadrant of the graph, that's where it's a positive 1 over x. The other graph, which we have over here, which is also a reciprocal graph, it has it in the negative quadrants of the graph. So this is where we have a negative 1 over x, or something along those lines. So here, this graph here is graph D. Now, as well as those 6 graphs there, you also need to have a recognition for the trigonometric graphs too. But this one here is just looking at your standard quadratic, cubic, reciprocal, and of course, straight line graphs. Okay, so in this question, we are looking at a quadratic sequence. Now, when we have a quadratic sequence, there are different methods that you can use. I know some people learn a formula for this, but I use the logical approach. So over to here, we're going to have a look what the difference is between these terms. Now, in the first instance, it's 2, then it's 4, then it's 6, and then it's 8, which means that there is a second difference to this sequence. The first is 2, and then 2, and then 2. Now, a second difference of 2 is a unique property to the square numbers. If you actually draw out the square numbers, you'll see 1, 4, 9, 16, they have a second difference of 2. We first get 3, then 5, then 7, and then the second difference is 2. So all that finding a second difference of 2 tells us is that it's somehow related to the square numbers. Now, that sequence up there is called n squared, and n squared has a second difference of 2. So whatever you get as your second difference, to find what goes in front of n squared, because it can be 2 or 3n squared, you have to divide the second difference by 2, and that tells us that it's 1n squared. Now 1n squared is the sequence that we've just written out. 1, 4, 9, 16. I'm going to put another one because we have 5 numbers in our sequence, and all we want to do is see, okay, well we know it's related to n squared, but how is it different? How does it differ from the sequence we've been given in the question? Now I tend to write that down as the difference. You can write it down as whatever you like, but to get from 1 to 1, that's a difference of 0. To get from 4 to 3, that's a difference of minus 1. And it's got to be careful when I say difference here, because normally a difference is always a positive value, but here we're just looking how we get from the sequence back to our original. So from 9 to 7, we take away 2, from 16 to 13, we take away 3, and from 25 to 21, we take away 4. Now ideally, we want this difference to be a fixed number. If they were all minus 1 or all minus 2, we could finish this nth term off and just say n squared minus 1 or n squared minus 2. Unfortunately, we have got the hardest version here, and that's where we now need to find the nth term of this sequence here. Now, one thing we can do is we know the nth term is starting with n squared, so we can sort of put that in terms of our final answer. But now we need to find the nth term of this sequence. So at this point, it's almost like forgetting about the entire question. Just imagine we had a question that just said, here's a sequence, find the nth term of that sequence. Well, in that scenario, we would again find the difference. In this case, it's minus 1, which means it's minus 1n. And then we find the difference from the negative 1 times table to this sequence here, and that is adding 2. You can go backwards from the 0 as well, if you would prefer. But here, if we do go backwards, or if we think about this, from negative 1 to 0 is adding 1, from negative 2 to 1 is adding 1. So this is plus 1 on the end of our minus 1 times table. So the sequence that we have there is just 1 bigger than the negative 1 times table. That's all that that part means. So this particular sequence is minus 1n plus 1, which of course you can just write as minus n plus 1, or you can leave the 1 in, it's up to you. So it's minus n plus 1, which is being sort of added on or subtracted from this sequence, whichever way you look at it. So there we go, n squared minus n plus 1 is our nth term for this quadratic sequence. Now our next question is looking at a graph transformation. So here it says the turning point on the graph of y equals g of x has coordinates negative 2, 7. Write down the coordinates of the turning point on the graph of y equals g of x minus 5. Now, if there is something within the bracket, like a +5 or a -5, it affects the x-coordinate. But when it's in the bracket, just like kind of like when we're solving quadratics, it does the opposite. So we know when you solve a quadratic and you flip the symbol, it's kind of a similar sort of idea to that, in the sense that it does the opposite of what we expect. So instead of taking away 5 from the x-coordinate, actually what this does is it adds 5 to the x-coordinate. So here the x-coordinate is -2, so -2, add 5, gives us 3. So our new x-coordinate would be 3, the y-coordinate remains unchanged, so that would be 7. So there we go, just adding 5 to the x-coordinate. The next part says the graph of y of f of x is shown on the grid, and we can see the graph on the grid to the right. On the grid, sketch the graph of y equals -x, f of -x, plus 4. Now, although we just spoke about how something in the bracket does the opposite, when it's a negative symbol like this, that's just asking us to change the sign on the x-coordinate. So you can't do the opposite of that. The opposite of that would be doing nothing. So here, it does change the sign in front of the x-coordinates. It also then wants us to add 4. Now, there's a couple of different ways you can do this. You can think of these as transformations. So a minus in the x there, which changes the values of the x-coordinates, actually does a reflection in the y-axis. But we can find that just by picking a few points. So we can pick a few here. Let's just pick these 3. Now the top one has an x-coordinate of -2. So that one would form an x-coordinate of +2. So we can kind of do these in 2 steps. So I've got that one there. The -5 would flip over to +5. And the +1 would flip over to the -1. And if there are any other whole number coordinates, we can do the same. There's a couple down here as well. Again, that 2 goes to -2, and the -6 down the bottom left there would go to +6. Now, if it was just -x, that would be the transformation that would take place. It's done a reflection in the y-axis. And there we go, we'd sketch it in like that. However, this particular one is also asking us to add 4. Now, when there is a number outside of the bracket, it affects the y-coordinates. And thankfully, unlike when it's in the bracket, it does do what we'd expect. So here, that would move it up by 4. Remember, the y-coordinates follow the y-axis. The y-axis goes up and down. So if we move this up by 4, it's going to finish the graph off. So we can move each point individually. So this top point, and I'll go from the top point there at the very top where the turning point is, up by 4. I'll go up to 7. The 2 points that are on the x-axis there will go up to 4, just here. And then the 2 very bottom points that are down at -7 are going to go up to -3, just here. So there we go. Our final curve that we're going to draw in goes up, and this one over this side goes up as well. And just trying to draw it in as best you can. The important part is that you go through those coordinates, and there we go, that would be our final graph. And obviously if we'd drawn this as a sketch in pencil, just to help us find it, we could get rid of that one, but there's our final one. So it has reflected in the y-axis when the x-coordinates change signs, and then it's also gone up by 4. And there we go, that is a graph transformation. Now this question is looking at perpendicular lines. So here it says find an equation of the line that passes through C and is perpendicular to AB. So if we kind of imagine a line which is perpendicular to AB, doesn't necessarily go through the middle of that line of course, but it might be something like this. So it's perpendicular to AB and it forms a right angle. Now drawing it in can help along the way, but ultimately we need to find out what the gradient of that line is. Now we can find the gradient of the line by looking at the coordinates A and B. Now B over here is the coordinate, and let's just have a think. The x-coordinate is 0, the y-coordinate is 4. A down here, the x-coordinate is -2 and the y-coordinate is 0. So if we want to find the gradient of AB, we can then find the gradient of this perpendicular line. So for the gradient, we will do the change in y divided by the change in x. So here, the y-coordinates go from 0 to 4. So 0 minus 4, or you can do 4 minus 0, and then over the change in x, which is -2, take away 0. So for that, you can also just think about it as a distance as well. You could do the positive versions. From 0 to 4 is 4, from -2 to 0 is 2. So we can actually just use the positives, which probably would have been nicer in this one, but -4 over -2, which is +2. So the gradient of AB is 2. If we want the perpendicular gradient, we have to do the negative reciprocal. So the negative reciprocal, we change the sign in front of that gradient so it becomes negative as it was +2, and then we do the reciprocal. The reciprocal of 2 is 1 over 2. So our perpendicular gradient for that perpendicular line is -1/2. So we know what our equation is going to look like. It's going to be y equals -1/2 x plus c. We just need to find what that y-intercept is, that value of c. To do that, we need a coordinate that's on that line, and it's told us that this one passes through the point C. So I just need to substitute that value, or those coordinates, into my line equation. So y is -1, that's equal to -1/2 multiplied by x, which is 5, and then plus c. Now in this circumstance here, we would likely just use the calculator just to make sure we get these values correct, but 1/2 times 5 is just 2.5, and it is -1/2 times 5. So that would just become -2.5. You could leave it as a fraction or a decimal, it's completely up to you. I'm going to write it as -2.5 plus c. To get the value of c now, we just need to add 2.5 to both sides of our equation. That will isolate c. We will then have the value of c. So c is equal to, and again you can do this on the calculator, but -1 plus 2.5 is equal to +1.5. Or you could write that as a fraction. If you want, you could leave it as 3 over 2. So for this one, we now know the value of c. All we're going to do is put this value of c in place of c in the equation that we'd already written. And here we go, we would have y equals -1/2 x plus 3 over 2. Now you can write those as decimals if you like. You can write -0.5x plus 1.5, but I tend to just leave the equation that I'm writing either as a fraction or as a decimal, but it's completely up to you as to how you write it. But there we go, there was dealing with perpendicular lines. And onto some graphical inequalities. Now here it says, on the grid, shade the region that satisfies all these inequalities. Now in order to draw these inequalities, we want to just change these symbols into equal signs. For the moment, we have y equals 1, we have x plus y equals 5, and we have y is equal to 2x. Now there's lots of different ways that you can draw these line equations. Y equals 1, there's just one way really, that is just a line that goes through y is equal to 1. So we're going to draw a straight line through y is equal to 1. Now if we have no equal to symbol on this symbol as well, we actually draw a dotted line. So for this one, I'm going to draw a dotted line across, just to show that it's not actually equal to this number here. But there we go, we can go across, and there is y equals 1. Now that's our nice easy equation in this one. But we have two others. Now you can, as we looked at before, when we looked at the quadratic graphs, you can do your table mode for this. So we can actually use table mode. However, some of these equations are relatively nice to draw, and I'd hope you could draw linear equations as it is. I'm going to go for this bottom one, as I think it's the easier of the two. It has a y-intercept of 0, as there's no number at the end, and it has a gradient of 2. So all I have to do is go 1 across, 2 up, 1 across, 2 up, and just follow that pattern. And that's going to draw that line for me. I just need to connect that together, again using my sort of dotted or dashed lines for that one, and of course using a ruler and a pencil. So there we go, there is my second line drawn. I just have one more to draw. Now this final line in the middle, x plus y is equal to 5, is actually a really nice line to draw because it just connects 5 and 5 on the x and y axes. However, if you wanted to use something like table mode, you could rearrange it so it's y equals, and you could actually write that as, and we'd have to minus x to the other side, y equals 5 minus x. That's completely up to you if you'd prefer to do it that way. But there we go, we've got the 2 points that they have to connect, so all we need to do is join those up using, again, a pencil and a ruler. And there we go. We now have lots of regions within the graph. So regions are sort of areas. So for example, this little section here is a region. We need to find the region that satisfies the inequalities. So to do this, I need to pick a coordinate and test it in my inequalities. However, we know from the first one, y has got to be bigger than 1. Now if I put a cross in some of the regions that we know it now can't be, so bigger than 1 means it has to be above that line y equals 1. So it can't be this little region here, it can't be this region, and it can't be this region. So I've cancelled off most of them already. I just need to look at the ones above. Now the next ones are relatively difficult to sort of very quickly or visually see whether it's above or below because they're slanted lines. So I tend to just pick a coordinate now. Now if I look at one of the lines, let's go for the x plus y equals 5. Let's pick a coordinate on this side. Let's go for this coordinate here, and hopefully it's not this one straight away because we'll have to test another one. But let's just have a look. So 4 and 3. I mean, obviously in an exam you'd hope that this was the first one straight away. But let's substitute that coordinate into the inequality and see what we get. So for 4, 3, x is 4, y is 3. So we would get in the first one here, 4 plus 3 is less than 5. Now 4 plus 3 is 7, and 7 is not less than 5. So we don't need to test it in the next inequality because that didn't work. So based on that one, it doesn't work. So I need to go for another region. Now this one here, inside this little triangle, would be a good one. Let's go with it. That's 2 and 2. Let's test that one out. So for 2 and 2, that x plus y inequality would be 2 plus 2 is less than 5. That works. So I need to test it in the next inequality. So y is greater than 2x. So 2 is bigger than, 2x is 2 times 2, so that's 4. 2 is not bigger than 4, so it's not that region. So there we go, I'll put a cross in there. In fact, let's get rid of that cross that I put originally and replace that with a little dot so we don't get confused between the two. So there we go, we've tested that region, and kind of at this point, I'd just be starting to get a little bit annoyed because I've already had to test a few coordinates out. So I'm going to have to test another one. Now I'm going to look for, in this region here, a nice whole number coordinate. So I'm going to try and go for this one, which is the coordinate 1, 3. Let's substitute that in. If it's not this one, we've only got one more left. So if we put it into the x plus y is less than 5, and this is the coordinate 1, 3 that we're using, we get 1 plus 3 is less than 5, which it is, that's correct, that's 4 is less than 5. And for the other one, y is 3, so 3 is greater than 2 times 1, 2. 3 is bigger than 2, so there we go, thankfully we've got it. Now it does want us to shade that in. When I'm shading it in, I don't need to draw a ton of shading, I just need to make it just obvious that that's the region that I'm shading in. So there we go, just a few lines just to show that that region's shaded, and that's the region that we were looking for. So there we go, testing those coordinates, really important. And there we go, there's some graphical inequalities. So for our next question, we're looking at forming and solving equations. It says here is a parallelogram. Now with a parallelogram, we know that the opposite sides are equal, and also the pairs of opposite angles are equal. So when we're looking at opposite angles, we're looking at sort of these ones here. We also have in a parallelogram, because these are parallel lines, we have co-interior angles. So these two angles here are also equal to 180 degrees, just like the bottom two are as well, basically any two that are next to each other. So that's all of the things that we need to know about a parallelogram. From there, we just need to be good at solving equations. So here we are given two options. We can either make an equation where we say this angle and this angle are equal, or we can make an equation where we say this angle and this angle are equal to 180. However, that option there leaves us with an x and a y in the equation. So we're going to start with these first two that just have x's in. That's going to allow us to form an equation with only x in that we can solve. So for that, we've got 5x minus 20 is equal to 2x plus 43. We can solve that equation. There's x's on both sides, so we have to get rid of the smallest x from both sides. we get 3x minus 20 is equal to 43. We then need to add the 20 to the other side, so 3x is equal to 63. And then dividing by 3, we get x is equal to 21. So we now have the value of x, and that's what it wanted, the value of x, and it wants the value of y. So if I substitute this value of x into this bottom angle is now 4y minus 5 lots of 21, which is 105 degrees. So I now have an equation. I know the size of this angle as well, and I know that they're both going to add up to 180. So let's also substitute the value of x into this one. I could use the bottom one as well, but I'm going to stick with the top one as I've gone for that one now. 2 lots of 21 is 42. So 42 plus 43 is this top right angle, and that is equal to 85. So if this top angle is 85, and the two of them have to add up to 180, well, I can do 180 minus 85, and that leaves me with 95 degrees for that bottom right angle. So 4y minus 105 equals 95. And then I've got a relatively nice equation to solve there, especially considering we're using a calculator at the moment. 4y is equal to 200, and therefore y is equal to 50. And there we go, there is forming and solving equations. Now obviously in that particular question we had an equation where we had x's on both sides, and we had an equation where we had an unknown on one side down the bottom there when we were solving for y. So all different types of equations, but the important part of this topic is to know your shape and angle facts. So in this one here we knew that the opposite angles in a parallelogram were equal, as well as that we knew opposite sides were equal, but we didn't have to deal with sides in this one because we were exclusively looking at the angles. But there we go, there's some forming and solving equations. So for this question we have some right angled triangles, and we're looking at Pythagoras and trigonometry. Now here it says work out the size of angle KLM, and KLM is this angle here. Now using trigonometry for right angled triangles we need at least two sides, so at the moment we've only got the 15. But we do have a connecting side with another triangle attached to it. So if we can find the length of that side, that would be the opposite side when we get there, and this is our hypotenuse. So we can use SOHCAHTOA to find that angle. We just need that missing side. So before we get started on finding the missing angle, we'll use Pythagoras' theorem on this right triangle here. So we have 7 centimeters and 4.5. They are two of the shorter sides. Pythagoras' theorem is a squared plus b squared is equal to c squared. So all we need to do is square both of those. We are finding the longest side here, so we will add them together. We're going to type that into our calculator. So 7 squared plus 4.5 squared gives us a value of 69.25. We just need to square root that answer. That will give us the length of the side. So square root of the answer. And it doesn't give us a very nice number. Of course, we're not going to get a very nice number if we're square rooting 69.25. But we do end up with quite a long decimal, so 8.321658489. Says to give your answer correct to 3 significant figures. Now at the moment, the answer that I have for that middle line is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 significant figures long. Now I could probably do it to 5 significant figures and it's not going to mess up my answer. However, I'm just going to leave that number in my calculator, and then when I come to use it in a second, I'll use my answer button just to put that number into my next working out. So I'm going to label it as 8.32 here. However, I am going to use the full number. So I now have a right angled triangle with O and H. So you need to know your 3 formulas, whether you use the ratios or whether you use formula triangles. I'm going to write it as formula triangles here. O and H is in our sine formula, so we will be using sine when looking for an angle. I cover up the S, and it's O divided by H. Now when finding an angle, we do have to press shift sign first, which brings up our sin minus 1, and we're just going to put our fraction in, which is O, which is the 8.32, over 15. Now if you are typing that number back in and not using the answer button, do type the full answer back in. I'm just going to press shift sign, use my fraction button, and then do the answer over 15. And when I press equals, I get 33.69537249. I didn't really need to write the whole number down there because it does only want it to 3 significant figures. So 1, 2, 3, chopping it after the 6, we get 33 point, so 9 after the 6, so 33.7. We are looking at an angle here, so that is degrees. So there we go, our final answer for that one is 33.7 degrees, and that was using Pythagoras and trigonometry. Okay, so looking at some further trigonometry, this is one of those types of questions that just involves everything. It says ABC is a triangle, D is a point on AB, work out the area of triangle BCD. Give your answer to 3 significant figures, but we'll deal with that right at the end. So triangle BCD is this triangle here. And let's just think about what we need in order to get the area of that triangle. Well, we've got an angle of 25. If we were to use that angle, and the formula for the area, we're going to be using the area is equal to half AB sine C. So if that angle is our C, we need the A and the B, meaning that we need this length here, let's call it X, and we would need this length here, let's call it Y. Now at the moment, of course, we have neither of those. So we need to have a look at the other triangle and think about how we could possibly get one of those lengths. Now, if we look at this triangle on the left, we have got enough information to find this side opposite the angle. We can use the cosine rule for that. So the cosine rule for a side length is a squared is equal to b squared plus c squared minus 2bc cos a. Now you can rearrange the letters in that formula, but I tend to just use one version of the formula, and I'll call the angle that I'm going to use my large A. Now as it so happens, it's got an A next to it anyway, but that is going to be my big A, and then the X that we're looking for there is going to be my little a. The other two sides are going to be B and C, so there we go, we can just plug these numbers in, and we'll find one of those first 2 lengths that we need. So if we put those into our formula, and it's completely up to you here, what I like to do is I like to figure out A by doing the square root of everything, and then putting everything in my formula all in one go. Completely up to you, but if you are answering these type of questions, I'd imagine you're quite happy to do that step there. So we would have 4.9 squared, and a kind of, you know, especially if you're sort of following along with me, sort of typing it in as you go, just to make sure that you're happy to type it into your calculator. Although it's not the hardest to type in, particularly after some of the other types of calculator use we've done. The next one would be 3.8 squared. So again, 3.8 squared, and then take away 2 times 4.9 times 3.8 cos 80, and it will open up a bracket, and that angle there goes in your bracket. So typing that into the calculator, we are going to get, I would imagine, quite a large number, and that's absolutely fine. It does say 3 significant figures, but we will write this out in full to start with. So 5.655381673. And there we go, that is that length X. Now for the moment, I'm just going to write 5 point, and let's just write 655. That's going just beyond the 3 significant figures there, writing 4. Just so it's labelled on the diagram. So now we need to figure out how on earth we're going to find side Y, because we still don't have enough information on that triangle on the right. Now we can use either the sine rule or the cosine rule, of course, to find missing side lengths. However, if we look at the easiest route to get there, we now have one other side length. Now ideally, we would like either the angle opposite that, so that we could then use the sine rule. We could pair this up, and if we know that angle, we'll know this angle here, and then we can do pairs of opposites. So it doesn't really matter which angle we find, but we'll be able to use the sine rule if we can get one of those angles. So that's kind of our next problem now. How do we get one of those angles? Well, looking at the triangle on the left again, is there a way we could get maybe this angle here, next to the other one within the triangle, next to that letter D, or maybe that top angle? Now we can definitely get that angle there, or the top angle, because we can use the sine rule on this triangle. On this triangle here, we also have pairs of opposites. So if we get rid of some of this working out, we'll swap to a different colour, we have this pair of opposites. The 80 is opposite the 5.655 we've just worked out, and the 4.9 is opposite this angle here. So if we use the sine rule to figure out that angle, we can do angles on a straight line to figure out on the other side, and then we'll be able to use the sine rule in our finishing triangle to find the length of y. And then of course we've still got to get the area of that triangle, so we have a lot to do. This is a huge question. So let's use the sine rule on this triangle on the left. So the sine rule is A over sine A is equal to B over sine B. And you can write equal to C over sine C as well. We only ever use two, so I just tend to label them A and B. Now, as it just so happens, we have actually labelled the A and B already from the previous working, and that works nicely for this one. So we can actually just stick with that labelling. If the letters were different, we would want to swap them around and sort of relabel it. But as it so happens, this works out quite nicely. So A is our 5.655 number, 5.655 over, and opposite that, our big A is 80, so over sine 80, and that's equal to, B is 4.9, so 4.9 over, and then we don't know the angle. So in this scenario here, where we are looking for an angle, we actually would normally flip the sine rule over, so make sure we have it set up for finding an angle. But we can just flip them over at this point. It doesn't matter, you can either put it all in the first place, or you can flip it over at a later stage. So I'm going to flip it over now. So we have sine 80 over 5.655 is equal to sine x over, and let's just go with the 4.9. There we go, I've labelled that x. I should probably get rid of the x now because I don't want us to get confused with the side length. Now we're trying to find this angle, so we'll call that x. Now we can rearrange this. To get sine x on its own, we need to multiply both sides by 4.9. And if we multiply both sides by 4.9, we'll have something we can type in our calculator and we will get that angle. So we have 4.9 sine 80, and that is over 5.655. That's equal to sine x. Now we don't want to know what sine x is, and hopefully you are sort of confident with trigonometry in the sense that we need to do the inverse of sine. You can type it all in one go, or you can type in 4.9 sine 80 over 5.655 and then do the inverse sine of your answer. That's how I'm going to do it. So I'm going to type in 4.9 sine of 80, and on the bottom 5.655. And when I type this in, I'm going to type in a few more of the decimals as well, just to make sure it's as accurate as it can be. I've got it written down over on the bottom right, so 7.3 at the end. We'll type that in, and we do get a decimal. It's 0.85 and a few more decimals there. So I want to do the inverse of my answer. I could write it in there if you want. I'm confident I've got the correct answer written in there though. I'm going to do sine minus 1 of my answer, and I do get 58.5689, a few more. I'm not going to round it, I'm just going to keep it as 58.5689. I'm just going to leave it there. It is a 4 afterwards, so technically I am rounding it, but that's going to be enough decimal places there, or significant figures as well. We've got it to 6 significant figures. It wants that answer to 3. I don't want to just sort of overcrowd everything with tons of numbers. There was actually only 2 numbers left, but that is enough for this angle. So I'm going to label that up here. That's 58.5689. You can already start to see, even with a whole page, you would start to get, this is going to start to get a little bit messy. So let's now move into this triangle. We've used the sine rule. We can move on to the angle next to it. So 180, take away my answer. And next to that now, this is 121.43. I'm going to round it to 2 decimal places now, or 5 significant figures, because it is starting to get to a point where there's just numbers everywhere. Now I can do the sine rule again. So if you're already happy with the sine rule, we're now doing the sine rule for lengths. I want to find this length here, which is opposite this 121. I can find the angle in the bottom right because it's angles in a triangle. So I'm going to do 121.43 plus 25, and then take that away from 180. So that leaves me over here with 33.8 and then it's 5, 6, 8, 9. Again, I've used the full number every time, so I get 5, 6, 8, 9, 4, 9. So at this stage, I'm just going to write the full number in so I don't get any rounding errors. And there we go, that angle there is opposite this 5.655. So I'm going to use the sine rule again. I'm going to do that over on the left, so it's quite a distance away from the shape now. I'm going to keep that top right space there for the final step. So using the sine rule, and again we need to label this up. So this time I'm going to call my y A and my angle big A, and then this 5.655 will become my B, and this will become my big B. And again, just using A over sine A. So we have y over sine of 121.43, and that is equal to the 5.655 over sine of 33.568, or it just round up for my bracket here, so 569. I need to rearrange this, so y is equal to, and then I'm going to have the sine 121 up on the top, so 5.655 sine 121.43 all over sine of 33.569. I can just type that all in one go. That is going to give me my answer. There's a lot to type in. So 5.655 sine 121.43, and on the bottom we have sine of 33.569. If I press equals now, I have got an answer for that side length, which I have called y. Y is equal to 8.726587.523. And again, I have used some rounded figures there, so this might be ever so slightly different if you've been using different rounding to me. Right, so that is the length up here. We now have 8.7265 and a few more decimals. Okay, so I now have all of the information that I need to work out the area of that triangle. If I was to redraw it, which might be helpful at this stage, it might actually not, because we're just sort of creating more writings and more drawings everywhere. We have the angle of 25. We have the side length over here, which is 5.655. And we have the side length on the other side now, which is 8.726, or 8.72, and that 6 would round up. Let's just keep it as 6.5. So I can now use half AB sine C. I can use my area of a triangle formula. This is going to finish the question, thankfully. There's a lot of working out up to this point. So I just need to type into my calculator 1/2 times A. It doesn't matter what order we put A and B in. So we've got 5.655 times 8.7265 times sine of 25, the angle that we're using there. So I need to type all of this in. 0.5 times 5.655 times 8.7265 times sine of 25. And there we go. Now all of that has led to a final answer for me, which has come out as 10.42775 and a few more decimals. I'm not going to worry too much though, because I do need to round this to 3 significant figures. So if I cut it after the 4, I get a final answer, which has come out as 10.4. So all of that, and I've got to a final answer. I'm going to write it down here, 10.4. This was an area, so it is centimetres squared. And there we go. That's the final answer after all of that working. Now you can see there was an awful lot. So it's not necessarily always going to be the case that you're going to have every single part of trigonometry within one question. The only thing we didn't really do there was using the cosine rule for an angle. But there we go, pretty much all of trigonometry within one question. And there you go, there is some further trigonometry. So with iterations, there are 2 variations of questions you can have. You can have iterations like this, where it's purely focusing on an equation, and you can have some real life iterations as well. So this one here is focusing on an equation based iteration, and for part A it says show that x cubed plus x equals 7 has a solution between 1 and 2. Now a solution here is a value that we can substitute in place of x, which would give us the answer 7. So if there is a solution between 1 and 2, what if we substitute 1 into x cubed plus x? It should be smaller than 7. And if we substitute 2 in place of x squared plus x cubed plus x, it should be greater than 7. So if we substitute them in, when we put x equals 1 in, we get 1 cubed plus 1, which is equal to 2. When we substitute x equals 2 in, we get 2 cubed plus 2, which is 8 plus 2, which is equal to 10. So based on these two values, there we go, we can say 7 is between 2 and 10. So therefore, there must be a solution between x equals 1 and x equals 2. For part B here, it says show that the equation can be rearranged to give x equals the cube root of 7 minus x. So on a question like this, we need to have a look at how the equation has actually changed. Well, the first thing I notice, of course, is the big cube root, which means at some point we're going to need to cube root as we have an x cubed. And as that's over everything, that's the last thing that we're going to have to do. The other thing that we can see is that there's a minus x here. So this plus x needs to be minus to the other side. Now some of these can be relatively complex and involve things like factorisation as well. But this is quite a nice one. We just have to minus x from both sides, which leaves us with x cubed equals 7 minus x. And then we would need to cube root both sides, and that would give us the cube root over there, and we'll write the final step, which is just x is equal to the cube root of 7 minus x. Now there's not actually many steps there, so be careful, as it does say show that, which does mean you need to show those little steps of working out and rearrangements very clearly, just to make sure that it's very clear exactly what you've done. Now part C here is using your calculator. So it's starting with x naught is equal to 2, use the iteration formula 3 times to find an estimate for a solution to the equation. So this little n plus 1 just means to find the next number, and the little xn here is our current number. And it says our current number, or our current solution, is x naught equals 2. So to find x1, we are going to type in the cube root of 7 minus, and then 2. So we can type that into our calculator, the cube root of 7 minus 2. And that gives me quite a long decimal, but it's 1.709. And then a few more decimals. I'm not going to write them all down or round it. I'm just going to leave that with some dots there, just to indicate that it does actually go on for quite a while. Now when I find x2, I'm going to leave that number on my calculator, and I'm going to do the cube root of 7 minus, and you can either type the whole thing in or use an answer button. So I'm going to use the answer button. I'm going to do 7 minus the previous answer, and that gives me 1.74241, and there are some more decimals. Now if you've got it typed in like that, you can just press equals again now. Now equals again will just do it for us. We will get our final answer. Again, on the calculator, it still just says 7 minus answer, except it's using that previous answer of 1.74. And that comes out as 1.738849506. Now notice there, I haven't rounded that answer, as that's my final answer. So I'm giving the full answer for that one, unless the question said to give my answer to a certain amount of decimal places. Now of course there are different variations of iterations. You have your real life iterations, and you can even have iterations where you have to substitute the number into 2 places. But I'll link the video in the description for that one, so you can have a look at some more iterations.
Okay, I'm looking at some 3D trigonometry. Now we've looked at quite a lot of the further trigonometry, which can be involved within 3D trigonometry as well, but this one here is a relatively nice one within a cuboid. It gives us some lengths and an angle in the question, so we want to label that on before we start going ahead with everything. We have 7.3 as this back length here, which is the same as the front. It might actually be easier if we write that on the front, so it's just out of the way a little bit. So 7.3. C to H, which is going up the side, is 8.1. And angle B to C to A is 48. Now if I go from B to C to A, which isn't the nicest one to draw, there we go, it creates this angle here. So that is my 48. It says find the size of the angle between AH and the plane ABCD. Now the plane is the flat surface on the base. So between AH, A to H goes up to here, and the plane, and we've already drawn that line in, and that's this angle here, sort of in the space inside the shape. So that's what we're trying to find, this angle. We'll call it X for now. Now if we look, that creates a right-angled triangle within the shape. And if I was kind of to draw that to the side, we have a right-angled triangle. We have the length of the height, well, the height of it, the length of this height here, 8.1. We don't have the base, but we have the 8.1, and we're looking for that angle. So if we can find the length of the base, well, we can use SOHCAHTOA and we can work out the angle. So there must be a way of working out that length. Now, if we look at the sort of base of the shape, this rectangle, and we were to draw that out, we don't know exactly the scale of it because we don't know all of the lengths here, but let's go with the 7.3 just here, and we'll split it up, and this here is 48 degrees. This is also 7.3 on the top. Could we work out this missing length in the middle? Of course, that is the base of this triangle. And the answer is yes. We have a right-angled triangle there. So we can use SOHCAHTOA. We have the opposite side, and this is the hypotenuse, as that's the right angle in the corner. So that is my SOH formula. So we're going to use sine to work out that length, and we are working out the hypotenuse. So we would cover up the H or rearrange your formula, whichever way you're doing this. So O divided by S would be 7.3 divided by sine 48. And there we go, we can type that into the calculator. That is 7.3 over sine 48, and that comes out as 9.82. So that 9.82 that we've just worked out, we could put a few more decimals with it if you would like. We want it to one decimal place, so let's do a few decimal places. That length there, being the diagonal from A to C, is also now the base of the triangle that we're looking at in the middle. So that here is 9.8231. And now I can do SOHCAHTOA all over again. So opposite this angle is the opposite. We don't have the hypotenuse, but we do have the adjacent. So this time we will use our tan formula. Whether you use it as a formula or whether you use a formula triangle, absolutely fine. When we're looking for the angle, we need to do the inverse of tan. So we're going to do tan minus 1, and then it's the O over the A. So 8.1 over 9.8231, and then we need to just type that into our calculator. So tan minus 1 of 8.1 over, and just make sure you do type this in correctly. It's a lot of working out to do if you then type an incorrect number in, 231, and that equals 39.508. A few more decimals, but I'm going to stop there because it did only want my answer to one decimal place, so we can cut it after the 5. It's a 0 afterwards, so that comes out as 39.5. Remembering this was an angle, so 39.5 degrees, and that is using SOHCAHTOA in some 3D trigonometry. Of course, not forgetting, you can have to do further trigonometry within SOHCAHTOA, but there we go, there was a nice, or a relatively nice question that only involved right-angled triangles. Okay, so looking at some bearings and trigonometry, this is our last question looking at trigonometry now. So here we've got lots of information, but it says it wants us to find the bearing of Chorlton from Acton. So if we join those two together, Chiltern and Acton, the bearing is all the way around this distance here. So we need to find this angle. If we find that angle, we can add that to the 37, we'll get our final answer. Now at the moment, we don't have a huge amount of information in order to get that. We'll probably be able to use the sine rule at some point, but we need to think about these parallel lines that we have with our north lines. Now the first one that stands out is that we have a co-interior angle just here. So to work out this angle at the top, we could do 180 take away 37, which tells us that is 143. We now have angles around a point and we can figure out this angle here, which is 67. Now using that information, and let's get rid of this arrow just here and our highlighting now, we can actually find the length of the line that we've drawn in. So to get this line here, we can use the cosine rule. So we'll call this our little a and this our big A. And the other two sides on that triangle there are our B and C. So for A, it's the square root of, and you can write A squared equals and then do the square root if you prefer, but it's B squared plus C squared minus 2BC cos A. So the value of A will be the square root of, and we have 8 squared plus 9 squared minus 2 times 8 times 9 cos, and then we have 67. So if we type that into our calculator, the square root of 8 squared plus 9 squared minus 2 times 8 times 9 cos of 67, we get A is equal to 9.4199. And that's our length down here, so 9.4199. Now we can actually use the sine rule. As we have a pair of opposites just there that we now have labelled, and this is another pair of opposites here. When using the sine rule for an angle, we do want to use our flipped version of the sine rule. So we're going to use, and we'll do this in the bottom left, sine A over little a is equal to sine B over little b. So let's call our angle here B and the opposite side little b. So we have sine of 67 over 9.4199 is equal to sine x, the angle that we're looking for, over 9. We can rearrange this now by multiplying the 9 to the other side. So we get 9 sine 67 over 9.4199 is equal to sine x. Now we can type that into our calculator and then we'll do the inverse of the answer. Or you can type it all in one go, completely up to you. I'm going to press sine minus 1 and I'm going to put the fraction into my calculator straight from there. So 9 sine 67 on the top, 9.4199 on the bottom. And there we go, our final angle there is 61.578 and a few more decimals. Now this question wants our answer to one decimal place, so we're going to need to round it anyway. But I need to add this angle, the 61.578, onto my 37. Now I may as well round this number, and that's 61.6, as it wants it to one decimal place. So if we add that to the 37, let's have a look. So 37 plus the 61.6, that gives us a total of 98.6 degrees. Now we want to write that as a bearing as well. So the third digit needs to be before the decimal place. So we have 098, there's our 3 digits, and then we have a 0.6 as well. So there's our final answer, 0.9 or 098.6 degrees, and that is our bearing of Chiltern from Acton. Okay, so looking at a frequency polygon. Now a frequency polygon, we need to plot on the midpoints of our groups. So between 0 and 10 is 5, 10 to 20 is 15, 20 to 30 is 25, and then we have 35 in our last one. We just need to plot these at the correct heights for the frequency. So from 5, we need to go up to 14, which is just here. From 15, we need to go up to 18. From 25, we need to go up to 26. And then from 35, we need to go up to 12. So up to 12, and there we go. Now a frequency polygon is just joined dot to dot with straight lines. So we're going to join each point. We would use a ruler for this, and just making nice straight lines between those 2 points. And there we go, that's your frequency polygon. For a scatter graph, regardless of what the question is asking, we need to draw a nice line of best fit. So if I draw a line of best fit for this one, where there's around about the same amount of points above and below, then we can start answering the question. It says here 1 point is an outlier. Now an outlier is one that's normally the furthest away from the line of best fit, and it doesn't tend to follow the usual trend. So over here there is a point which is an outlier. It says write down the coordinates of that. If you look down from that point, you can see that there is 100 on the x-axis, and on the y-axis it's sitting right next to 18. So 118 are our coordinates. For another day, 370 cars pass this point, and this is about the carbon monoxide levels for a certain amount of cars. It says estimate the carbon monoxide level for this day. So we need to find 370, which is 3 squares before 400. Make sure that you check the scale. This is 370. And then we're going to go up to the graph from 370, and then we're going to go across from that point and drawing that with nice straight lines. Now mine comes out as 14. Yours might be slightly above or below that, but mine came out as 14, and that's in milligrams per meter cubed, which I've just spotted on the axes there. The final part here says, Alfie says, because there's an outlier, there's no correlation. Is Alfie correct? You must give a reason for your answer. Now we can already see that there is in fact a positive correlation, and actually the outlier is just something that we would disregard. You might have used in other subjects the word anomaly. It doesn't mean that there's no correlation, it just means that there was one particular day where there was an anomaly. So any of that explanation there stating that it does in fact have a positive correlation and that we would just disregard the outlier would be a perfectly fine answer. But there we go, that's how we would use a scatter graph. Now with grouped frequency, we could be asked multiple different things to work out. This particular one is asking us for the modal class interval. Now modal is just another word for the mode, which is the most common. So we want to have a look at the number of adults in this question, and it's about their foot length, and see where the most are. Now the most are in this category here, so we would just write down the category 22 to 24, and there we go, that's our modal class interval. It then says as well to calculate the mean. Now when we work out the mean, we always just multiply across the rows, get the totals, and then divide by how many there are. And in this case, there are 40 adults. But with group frequency, we have to use the midpoints, and that's why we are only finding an estimate. We don't actually know the size of people's feet in these particular categories, but we use an estimate to get an estimated total. So we'll write down all of the midpoints. Remembering you can add the start and the end of the category and divide your answer by 2, and that will also give you that midpoint. So just typing these in on a calculator, 17 times 3 is 51, 19 times 6 is 114, 21 times 10 is 210, 12 times 23 is 276, and 9 times 25 is 225. Now we just need to add all of those together, so add them all up really carefully on your calculator. You don't want to miss a number or type it in too quickly. We get a total of 876. Now we were told that there was 40 adults. If not, we could find them there anyway. So we just need to divide our answer by 40, and that's going to give us our estimated mean, and that comes out as 21.9. Now always check your answer, make sure it makes sense. 21.9 falls into our range of data here that goes from 16 to 26, and 21.9 would fall into this category here, which is close to the middle. In fact, that category is actually in the middle. So there we go, 21.9 is our mean. Now with sampling and bias, it's a relatively nice topic. We're just looking at proportion. It says here that Sam takes a sample of 50 people. It says that there are 700 people in a fitness club. How many sports bags should Sam order? Well, here he had 17 people that wanted the sports bag, and that was 17 out of 50. So if we're looking at 700 people, we just need to work out that fraction of 700. So you could divide by 50 and times by 17, just doing a fraction of an amount. Of course, you could always look at this as a fraction out of 700 as well and make an equivalent fraction. Now 700 divided by 50 on the calculator tells us that we need to multiply by 14 to make that equivalent fraction. So if we do the same to the top as well, 14 times 17 is 238. So there we go, our answer would be 238. Now this question says to write down any assumptions you made and explain how this could affect your answer. So in this type of question, we are assuming that the sample represents the rest of the people. If the sample does not represent the rest of the people, then our answer could be bigger or smaller. And notice how I emphasised the fact that I mentioned my answer. So this is specifically asking you, how does it affect your answer? So we assume the sample represents the rest of the people. If not, our answer would be bigger or smaller. And there we go, that's sampling and bias. Okay, so looking at a stem and leaf diagram with a box plot. Now for a box plot, it's quite nice to plot the lowest and the highest value. And we can see that in the stem and leaf. We have this number here, and also this one just here. Look at the key to make sure that you know what those numbers represent. The smallest number there representing 173. So that's just here. Check the scale on your box plot just to make sure that each square is 1. If not, obviously just be careful when you're plotting that. 219 is just before the 220, and there we go, that's our smallest and largest value. Now to find the median and quartiles, particularly when we have all of those three to find, I would take a statistical approach for 23 flowers here, rather than crossing all the numbers off and having to then find the quartiles inside all the crossed off numbers. So here, 23, add 1, divide it by 2, that tells you where the middle is. So that's 24 divided by 2, that's the 12th number. So I just need to count along, and I'll underline them so you can see my counting. 6, 7, 8, 9, 10, 11, 12, and there is the middle, 197. So going down from 197, that draws our median. You might want to label these. I'm just going to label it as the median, 197. I then want to find the lower quartile and the upper quartile. I'm going to label them both here just so I don't forget them as I'm doing them, just in case I need to check them. And then to find the quartiles, we do the same as what we did for the median, add 1, but for a quarter, we divide by 4, and we get the answer 6. So we're looking at the 6th number, so that's 1, 2, 3, 4, 5, 6 from the start. There's our lower quartile, and that is 188. And then 1, 2, 3, 4, 5, 6 from the end, and there's our upper quartile, and that's 209. So plotting those on, we have 188, which is 2 before 190, and we have the 209, which is 1 before 210, and then there we go, we can join this together, and that's what our box plot looks like. And there we go, there is drawing a box plot and using a stem and leaf to find different averages. Now for our next question, we are looking at some percentage profit. It says here, Emily buys a pack of 12 bottles of water. The pack costs £5.64. She sells all 12 bottles for 50p. Work out Emily's percentage profit and give your answer to one decimal place. So to start with, the original cost was £5.64. When we're looking at percentage profit, we just want to do the profit or the change, because they might have made a loss as well, over the original cost, and then multiply that by 100 to turn it into a percentage. So here we actually need to work out the profit. So the original we already have, £5.64. So to work out the profit, we need to work out what she actually sold them for. So here we have 12 times 0.5 or 50p. We can do it in pence and then convert it. I've just converted it first, and that comes out as £6. So £6 is what she sold them for. She paid £5.64. So if we work this out, it will tell us our profit. So 6 take away £5.64, and that is equal to 0.36. So the profit she made is 36 pence. It's up to you whether you keep it in pence or convert it all into pounds, but I've got it in pounds. So I've got the profit, 0.36, over the original, £5.64, and I just want to multiply that by 100, just so that turns it into a percentage for me. 0.36 times £5 over £5.64. I'm just going to press times 100 straight away, just make sure it's not within the fraction there. And there we go, it comes out as 6.38297. There's a lot of decimals here, so I'm going to stop there because it does only want my answer to one decimal place. So I'll chop it after the 3, and that is 6.4%. And there we go, that is Emily's percentage
profit. Now for cumulative frequency, when we are plotting a cumulative frequency graph, we need to remember that we plot on the endpoints. You also need to check to see, is this the cumulative frequency or is it the frequency? If it's the frequency, you have to add up going down the rows there, just to make sure you get the cumulative total. As an example, if this wasn't the cumulative frequency, you've got 10 in the first, 26 in the next, so that'd be a total of 36. However, this is the cumulative frequency that's given to us, so we don't need to worry about that aspect, we just need to actually draw the curve. So I'm going to plot from 30 up to a cumulative frequency of 10, and that is just here. I then go up in tens, so 40, 50, 60, 70, plotting on those numbers, so 26 is the next one, just here. 50 goes up to 58, and that is just there. Then we have 66, which is just here, and our final 70 goes up to 70, which is right at the top of the graph there. Now there's one more point that we actually have to plot, and that is the starting number. So we have to plot this starting on 20 down at 0 there, not just to the origin. So this is a good example of a question where you have to think about that starting point. Now a cumulative frequency graph, we do join up with a nice smooth curve. So we want to freehand sketch this one in, drawing it nice and smooth, and there we go, that is our cumulative frequency graph. Now it says here to use the graph to find an estimate for the median. So the median, we want to look at how many people there are in total, and there were 70. So if we divide that by 2, we know the median is going to be at 35. So we need to find 35 on my graph, which is just here, and it does say estimate, so we don't need to worry about adding 1 and halving or anything like that when we're doing estimates. So we just need to go across with a ruler, connect it to the curve, and then whatever we're on there, we're going to go down to the other point on the x-axis, and that comes out as 1, 2, 3, so that is 43. So my median comes out as 43, and there we go, there is the median. It also says here, Freya says more than 60% of the people in the office are between 35 and 55 years old. Use your graph to determine if Freya is correct. Now this is a little bit of a pain because we do have to draw lots of lines on the diagram now to find this. So I'm going to go up from 35 and 55. I'm going to find out how many people that is. So if I go across from there, again being really accurate here, there we go, that is 16. And then I'm also going to go up from 55, again trying to draw this as accurately as I can, but you want to make sure you use a ruler and a pencil for going across on these. And there we go, there's our next one, and that is 62. So if we have a look, well, 62 take away 16 is the amount of people in that section. So 62 take away 16 is 46 people. Now, we want to compare that to the 60% because she says more than 60%. So if we work out 60% of 70, there we go, 60% of 70, and whatever method you prefer for that, I'm going to do 70. I'm just going to divide by 100, which gets me 1%, and times by 60, and that gets me 42 people. Well, 60% is 42 people, and we have 46 people. So no, Freya is going to be correct actually, because more than 60% of the people are between 35 and 55. So we would say yes, because 60% of the people is 42, we have 46 people. So use your graph to determine if Freya is correct. So yes, Freya is correct. There we go, and we have our working out to back that up. More than 60% are between 35 and 55. Okay, so looking at some compound interest. This question here says Charlie invests X pounds in Better Investments for 3 years and Sadia invests X pounds in Country Bank for 3 years. Now, as they both have an X with them, that means they've both invested the same amount of money. It says at the end of 3 years, the value of Charlie's investment is £344,605. Work out the value of Sadia's investment at the end of 3 years. So we need to know how much they invested, and that's what we're going to use Charlie's final amount to figure out. Once we've got that, we'll work out what Sadia gets.
Now this is some reverse compound interest, so we need to reverse this process. So we need to know exactly what calculation we would have typed in for Charlie in Better Investments if we knew his starting amount. Well, we'll call his starting amount X, so we would take his starting amount, X, and we would have multiplied that by 1 point, and then whatever this is as a decimal, so 2.5% is 0.025, so 1.025, and he's invested that for 3 years. And as a result, we got the answer 344,605. So to figure out what that starting amount was, we just need to divide both sides by 1.025 cubed, and we'll divide this answer here by 1.025 cubed. There we go, that's going to tell us his starting amount. So let's type that in, 344,605 divided by 1.025 cubed, and that comes out as a starting amount, 320,000. There we go, and that is the value of X. So the starting amount is 320,000. So that's what Sadia has at the start. We've now worked this out, £320,000. So now Sadia invests into Country Bank. She gets 2% for the first 2 years and then 3.5% for each extra year. So we're going to first work out how much she gets for that 2%. So 320,000 multiplied by 1 point. 2% is 0.02, so 1.02. And we're going to do to the power of 2 there because it's for 2 years. And then we'll deal with the 3.5%, which is 0.035. So we'll start by working that out. 320,000 times 1.02 to the power of 2. And that gives us a total of £332,928. So that's what Sadia has after 2 years. So we're going to do 332,928 times 1.035 this time for the 3.5%. We don't need to put a power with that because this is the 3rd year. So I can just press times 1.035 and I get my final answer, which is £344,580.48. And there we go, that's our final answer. At the end of 3 years, Sadia would have £344,580.48. And there we go, that's our final answer. Now, there's another compound interest question here. As this reverse compound interest is one just to be careful of, but this question here does have 5 years, and we're trying to work out the percentage. So it says here Natasha invests £6,000 for 5 years. The investment gets compound interest of X% per annum, and at the end of 5 years, the investment is worth £8,029.35. So this time we're working out the percentage. So it's different to the previous, even though they are both reverse compound interest questions. Now, if we knew the percentage, we would do 6,000 multiplied by, and it's a bit of a strange one because we don't know the number there, but it would be 1 point, usually O something, okay, because it's normally a single digit. So we don't know what it is, and that's what we're going to need to figure out. So for the moment, let's just call that multiplier the letter X, as that's what it's told us is a percentage. It's going to be to the power of 5, because there's 5 years, and we're going to get the answer £8,029.35. So this isn't too bad to do, because at this point we just need to divide both sides by 6,000 so that we'll know what x to the power of 5 is. It's more the multiplier at the end we're going to be really careful of. So that would leave us with x to the power of 5 is equal to, and we have £8,029.35 divided by 6,000, and that comes out as 1.338225, but this is x to the power of 5. So we need to do the 5th root of this number. So just like when you reverse a square root or a cube root, here we just need to do a 5th root. And there is a button on most calculators which is a square root button with like a little square next to it. So mine is behind a button that has an X with a little square on it. So I have to press Shift to get that button, and then I can put a 5 in the root box, and then type in 1.338225, press equals, and I get x is equal to 1.05, and then lots of 9s. There's 4 9s there, 1, 2, 3, 4, 5 9s, 0, 8. Now, because this amount of money in the question was likely rounded to the nearest penny, it has changed this ever so slightly. So you can see the most likely thing is that this is 1.06. All those 9s there, it's so close to 6, and that's just probably because the amount of money has been rounded to the nearest penny. So here, the multiplier that would have been used would have been 1.06. So up here, where we were thinking about, well, what would this number have been? Well, if the number there is a 6, that would relate to 6%. And there we go. And that's the exact answer that we would get. So the value of x, the actual percentage, is 6%. That's what would go in the multiplier there if we were using 6%. And there we go. That is some reverse compound interest. Okay, so in this question, we're going to be having a look at exchange rates, but also some unit conversions as well. So it says here, in London, 1 litre of petrol costs 108.9 pence. In New York, 1 US gallon of petrol costs $2.83. It then gives us the conversion from gallons to litres and the conversion from pounds to dollars. It says in which city is the petrol better value for money. Now, in this type of situation, we need both of these to be in the same units and in the same currency. So I'm going to start by converting the currency and having a look at in London. So here it's given to us in pence, but we want that in pounds. So that's £1 and 8p, but also has the 9 after it there. So we have £1 and 8 with a little bit after. There we go, put a decimal of a penny. So if we want that in pounds, then we'll leave that as it is. And it's already told us that that is 1 litre. Now that's ideal. So 1 litre is £1 and 8 with that little 9 after it. If it was higher than that, if it told us something like 5 litres, then of course we could divide that by 5 or whatever it was to get down to 1 litre. But this has already given us 1 litre, which is ideal. So the second one has given it to us in dollars. So we want to convert this into pounds. Now you can see in our exchange rate here, the dollar number is bigger than the pound number. So we need to divide by 1.46 to turn this into pounds. We're just going to do that on the calculator. So 2.83 divided by 1.46. And that comes out as, and it's a very, very long decimal, but we have 1.938356164, and the 3 and the 4 have a recurring pattern. There we go, so all the way from the 3 to the 4 is recurring. And we're not going to need to worry too much because we are only comparing the value, so we just want to know which is better value. Now also, we've been told that this is 1 gallon. So if we want to turn that into litres, well, we've been told here that 1 gallon is 3.785 litres. Now we want to compare this as 1 litre. So we have 3.785 litres, which is equal to this £1.93 with the 8356164 number, which I am just going to leave on my calculator because that's really awkward to have to type back in. Now I want to know the value, not for 3.785 litres, but I want to know the value of 1 litre. So to get there, I just need to divide by 3.785, and that's going to tell me the value of 1 litre. I'll just do the same to the other side as well. So if we do that, we have the big long decimal there divided by 3.785, and that comes out as 0.512115235. Now ultimately we don't need to write all those decimals because it was £1 and 8 pence in London, and in New York it's only, and if we round it, 51 pence. So in terms of where it's better value, we would say New York is better value. I won't write down all the words there. We'll just say New York is better value, and obviously we have our working out that shows that 1 litre in London is £1 and 8 pence, and 1 litre in New York is 51 pence. And there we go, there's looking at some exchange rates and some unit conversions. Now this next question is looking at pressure, and we are given the pressure is equal to force divided by area formula. It says a box in the shape of a cuboid is placed on a horizontal floor. It doesn't give us a picture of that, but we can sort of imagine what that looks like. We have a cuboid, there we go, and that is on a horizontal floor, and there is our cuboid. It says the box exerts a force of 180 newtons on the floor. The box exerts a pressure of 187.5 newtons per metre squared on the floor. The face in contact with the floor is a rectangle of length 1.2, let's label that, and width of x. So we don't know what the width is. Work out the value of x. Now, if we can figure out what the area of that rectangle is, then we can figure out the missing length. So let's have a look at what we've got. Now, we have the pressure at the start of our formula, and we've been told the pressure is 187.5. So that is equal to the force, which is 180, divided by the area. So we'll put the area just below. So we need to figure out what number we have to divide into 180 to get 187.5. Now, when we have things like this, these can just be switched over. Now, there is a process to that. You multiply the area to the other side. Let's call the area A, and then you would divide 187.5 back to the other side. But you can get away with this quite quickly just by switching them. So A is equal to 180 divided by 187.5. So if we type that into our calculator, 180 divided by 187.5, that comes out as 0.96. There we go. So 0.96 is the area, and it's in metres, so that's metre squared. So the area of the base of this rectangle here is 0.96 metres squared. We want to know the width. Well, length times width is the area for a rectangle. So 1.2 multiplied by x is equal to 0.96. To find the value of 1x, which is what we want to know, we just need to divide by 1.2. So divide both sides by 1.2, and we will have our width, and that comes out as 0.8. And there we go, that is the width of the rectangle, 0.8 metres. And there we go, there is some reverse pressure to find the area. So moving on to some speed, distance and time. It says here Jessica runs for 15 minutes at an average speed of 6 miles per hour. She then runs for 40 minutes at an average speed of 9 miles per hour. It takes Amy 45 minutes to run the same total distance that Jessica runs. Work out Amy's average speed. Now it's completely up to you what method you use here. You can use a non-calculator method, or we can use a calculator method. As we have a calculator, we'll use a calculator method here, but you can always check out the non-calculator methods, which I'll link in the description as well. So we have speed, distance and time, and we have in each scenario here a speed and a time, so we can work out a distance. So if we want to work out distance, we just do speed multiplied by time. The only thing we need to be careful of is that we write both of these in hours, which is just writing them as a fraction over 60, so 15 over 60, which is 1/4 of an hour, and 40 is 40 over 60. So you don't need to simplify those, you can just leave them as fractions out of 60. That's going to make it easier for us. So in the first part of this, Jessica runs for 15 minutes at an average speed of 6. So 6 multiplied by the time, which is 15 over 60. There we go, and that's going to give us her distance for that first part, and we'll just type that into the calculator, 15 over 60. And that comes out as 1.5. So she runs 1.5, we were looking at miles, so I'll write miles with that, so I recognise that it's a distance. Now in the second part, she runs for 40 minutes at an average speed of 9 miles an hour. So that's 9 as the speed, times 40 over 60. And again, we'll just type that into the calculator, times 40 over 60, and that comes out as 6 miles. So in total, she has run 7.5 miles. Now it says here, if Amy takes 45 minutes to run the same total distance that Jessica runs, work out Amy's average speed. So we need to do a formula again, because this time we are working out speed. So speed, distance and time. We are working out a speed, so we need to do distance divided by time. Again, we have 45 minutes, which is 45 out of 60, if we write that in hours again. And then we can use that formula to get our final answer. So the distance we already know is 7.5, and we need to divide that by the time, which is 45 over 60. And if we type that into our calculator, 7.5 divided by 45 over 60, that gives us a final answer of 10. So it says here, work out Amy's average speed. Well, she is going 10 miles per hour. And there we go. It wanted us to give our answer in miles per hour. And the reason that we were converting everything into fractions there was because it wanted the answer in miles per hour. So there we go. We've got our answer in miles per hour. And there is our speed, distance and time question. Now, when we have density, mass and volume mixtures, I like to lay it out in a particular way. But it says here the density of ethanol is 1.09, the density of propylene is 0.97, and then it says 60 litres of ethanol are mixed with 128 litres of propylene to make 188 litres of antifreeze. Work out the density of the antifreeze. Now, the formula for density is that density is equal to mass divided by volume, and again we can use a formula triangle. So here we have lots of information. We've got lots of things getting mixed together. When we have this scenario, I like to draw it in a two-way table, just to keep everything really organised and clear as to what we have and what we're looking for. So we'll have a density, a mass and a volume for each thing. We have the ethanol, we have the propylene, and then we have the antifreeze. And there we go, I'm going to write the antifreeze there. And let's see what we've got. We have the density of ethanol, 1.09. We have the density of propylene, 0.97. We can't add those together because we don't know the exact ratios that are being mixed. So that's what we're going to kind of work out. We have a volume given to us. That's what the litres are. And sometimes litres will be given to us in centimetres cubed. But here we have a litre being 60 litres for the ethanol and 128 litres for the propylene. And in total, that makes 188 litres. So there we go. Overall, that is all the information that we have been given. Now we want to actually work out the mass of each. So here we have a mass that we can work out. We just need to cover up the mass and do density times volume. Now you'll notice in this question that part of it is in centimetres cubed and part of it is in litres. Now it's fine for us to keep the answers in litres here because we're going to keep it all in proportion, and as long as we keep all of our numbers the same, well actually once we come to work out the density anyway, it's going to stay in that same proportion. So it's absolutely fine for us to leave this in litres and not worry about the fact that those are different units, but quite a unique scenario in this question. For working out the mass though, we are going to do this multiplication. So I'm going to write my working out to the side for this first one, which is 60 multiplied by 1.09. So 60 times 1.09, there we go, and that comes out as, when we multiply them together, 65.4. So that is 65.4. I can then work out the mass of the propylene, just here, by doing the volume, 128 times 0.97. So 128 times 0.97. There we go, and that's going to give me the mass of the propylene, and that comes out as 124.16. Now we can add the masses together. If they're being combined, then their overall mass is just adding them together. So our total mass is 189.56. And then again, looking at our density formula, density is equal to mass divided by volume. So to find the density, we'll do the mass divided by the volume, and that's going to finish this off, which is 189.56 divided by the 188. We'll just type that in on the calculator, and that gives us a final answer here, which comes out as 1.00829. There's a lot of decimals here, but it does want my answer to 2 decimal places. So if we chop it after the 0, that is going to round to 2 decimal places as 1.01, and that'll be in grams per centimetre cubed. And there we go, there is our density question where we had a mixture involved. Okay, so there are different types of trigonometric graphs. This is quite a nice question. It says here is a graph of y equals sine x between 0 and 360. We've got a sketch of the graph. It says using this graph, find estimates of all four solutions of sine x equals 0.6, but between 0 and 720. Now if we look for where sine x is equal to 0.6, well, if we find 0.6 on our axes, which is close to here, that's 0.5, it'd be one square above that, so we would go along and we would hit the curve right here. If we keep going, you can actually see that there is another point where it would hit the curve, and that's just here. Now if we get those two solutions, and again it is just estimates, so I'm going to read this just as carefully as I can and try and get the answer as best as I can. Now between 90 and 180, or between 0 and 90, there are 5, 10, 15 squares. So if I do 90 divided by 15, it tells me that each square is equal to 6. So this here is 30, and that there is 36. So I have one solution where we have x will be equal to 36. I have another solution over here. I could probably work backwards. Let's have a look. So each one of these goes up in 30. So we have 120, 150. Now that's one square before the 150. So that would be 144. So I also have x is equal to 144. Now this particular question is asking us to find the solutions between 0 and 720. And that's because even though it's not shown, this graph here could be extended. Now I can't draw that perfectly scaled, but the curve would carry on over to here. Now what we need to find is the other solutions. If we imagine that this carried on and we had the graph perfectly drawn, of course we could actually read them. But if we imagine it's over here, it gives us a visual idea of exactly what we're actually looking for. Now if we think about this, to get from this point over here to this point over here, there is a jump that we can go through to actually move to that position. As that has actually jumped forward an additional 360 degrees, or 360 on the x-axis. So if we jump forward an additional 360, well, 360 add the 36, which we could write over here, plus 36, and that would give me 396. We also have the next one, which is again 360 ahead of that 144. So if we do 360, add 144, that would give me, and again just be really careful, I know that's not a difficult addition there, but as we are using a calculator, we can always type it in if you need to, and that gets you 504. So we have two more solutions. X is equal to 396 and x is equal to 504. And there we go, we've got our four solutions.
We have some similar
trigonometric
shapes.
graph.
It says here two solid cones are mathematically similar. Cone A has a volume of 120, cone B has a volume of 960. Work out the ratio of the surface area of cone A to the surface area of cone B. Now there's a couple of different ways that we can look at this. We can just write this as a ratio straight away. A to B would be 120 to 960. However, that is a volume ratio. Now if you type that into your calculator as a fraction, it'll actually simplify it for you. So 120 over 960, and if I type that into my calculator, over 960, it comes out as 1 over 8, which actually simplifies the ratio, so that's 1 to 8. Now that's one way of doing it, and obviously this is still a volume ratio, but the other way, to find the scale factor, you do the larger shape, 960, divided by 120, and that gives us 8. That tells us that one is 8 times the size of the other, which again is the ratio 1 to 8. So it doesn't matter which way we do this, but we're going to get that ratio 1 to 8 as our volume ratio. Now if I label this down here, and this is volume, to get down or to change it into area, we first have to go down to a length ratio. Now to do that,
to move between length and volume, you either cube or cube root. We're going down, so we need to cube root these numbers. And when we cube root the numbers, 1 is always going to stay as 1, and the cube root of 8 is 2. So this means the lengths are in the ratio 1 to 2. To get to area, the process to move between length and area is squaring and square rooting. We're going up to area, so we're going to square these, and that's going to give us our area ratio, which is 1 to 4. And there we go, that is our ratio. 1 to 4 would be our final answer. And there we go, that's moving between length, area, and volume scale factors. You just need to be aware you can't jump straight from volume to area and straight from area to volume. You do have to go down to length. So had we have had an area scale factor to start with, we'd have gone down to length by square rooting, and then we'd have gone up to volume by cubing. So essentially exactly what we've done here, but just the squaring and cubing would be slightly different because we'd be going to area to length first, which would be square rooting, and then going to volume, which would be cubing. And there we go, that is our similar shapes question. Okay, so in this question, we're looking at angles in parallel lines. Now it says here that A to E, DBG and CF are parallel. D to A, D to B and D to C are all the same length, and we are shown that anyway because it gives us these additional lines on these triangles here, which straight away is telling us that they are isosceles triangles. It says that EAB is equal to BCF, which is also equal to 38. Work out the size of angle X, and you must show your working. So, for starters, there are sort of two sets of parallel lines put together in this one. And above and below this central line, they are identical. We know they're identical because we have that 38 above and below. But we want to have a look between two of the parallel lines to start with. We want to see if there's a connecting line that goes between the two, or we can find any alternate, corresponding or co-interior angles. Now the first thing that stands out to me is that we can make this nice Z shape which hooks in this 38 and gives us an alternate angle just up there. So this also has to be 38. Now it doesn't tell us to give reasons in this question, but here the reason that that is 38 is because alternate angles are equal. And in a lot of questions it does ask you to give the reasons. We don't need to in this one, but just so you know, along our working out, that's why it's 38. Now we can almost now come away from all of this image, and we're going to now look at and sort of zoom in on this triangle here, because we've already said that's an isosceles triangle because two lines are the same length. On an isosceles triangle, base angles are equal, so this here is 38 as well. And although we're not giving the reason, we have base angles in an isosceles are equal, and that comes up quite a lot. So there we go. Base angles in an isosceles are equal. We can now find the top angle within the triangle, so this one just here, because angles in a triangle add up to 180. So we can do 180, and again it does say you must show your working, take away, and then we have the two 38s, so 38 plus 38, you could work that out and then take it away from 180. I'm just going to type it all in one go. So 180, take away 38 plus 38 in brackets, and that gives us 104 degrees. So that one there is 104. Now, it's not always going to be like this, but because that is almost reflected up to the top, in other words, all of the angles above are exactly the same because it's the same diagram, just sort of flipped upside down on top, that means this here is also 104. So to find that angle X, that is the missing angle around a point. Angles around a point add up to 360. So to find our final angle here, we would do 360, the angles around a point, subtract the two 104s, so 104 plus 104. And there we go. We can type that in, 360, take away 104 plus 104, and that gives us 152 degrees as our final answer. And there we go. And if you wanted to write a reason along with that, it's because angles around a point add up to 360 degrees. And there we go. There were some angles in parallel lines and also involving some isosceles triangles. Okay, so this question is looking at a cylinder. It says here, Karina has 4 tanks on her tractor. Each tank is a cylinder with diameter 80 and height 160. The 4 tanks are going to be filled completely with a mixture of fertiliser and water. The fertiliser has to be mixed with water in the ratio 1 to 100 by volume. Karina has 32 litres of fertiliser. And it tells us here that 1 litre is equal to 1,000 centimetre cubed. Has Karina enough fertiliser for the 4 tanks? You must show how you get your answer. Well, for starters, we need to actually work out the volume of one of these cylinders. So the volume of a cylinder is the same as any other prism. You get the area of the cross-section and times it by the height. Now the area of the cross-section here is a circle, so we need to get the area of this circle. To do that, we want to know what the radius is. The radius is half of the diameter, so that's going to be 40 centimetres, and then we're going to use our formula pi r squared. Once we've done that, we'll times it by the height, and that's the volume of the cylinder. So if we work that out, that's going to be pi times 40 squared, and we can either type that in and then times by 160, or we can just times by 160 straight away. And let's just write that down then. So pi times 40 squared times 160, and that gives us a very large volume here, but we get 804,247.7193. And there we go, that is the volume of one tank, 804,247.7193 centimetres cubed. Now it says here that we are going to have 4 tanks. Well, she has 4 tanks, so we need to multiply this by 4. That's going to give us the volume of all 4. So if we press times 4 on the calculator, we're starting to get to some very large numbers now. That's absolutely fine though, just make sure we write them all down. So we have 321,6990.877. So that's 3.2 million centimetre cubed. Right, so we're getting some very large numbers. Now, it says here, Karina has 32 litres of fertiliser, and it's going to be mixed in the ratio with water 1 to 100. So we're going to need to work out exactly how much volume we have here, but that's given to us in litres, and we're currently working in centimetre cubed. So completely up to you. You could either convert the 32 litres into centimetre cubed and keep dealing with very large numbers, or we could turn this volume now into litres, and we can do that just by dividing by 1,000, as it's 1 litre for 1,000 centimetre cubed. So if we divide that by 1,000, at least we're going to get some slightly smaller numbers. So here in litres now, the 4 tanks is 3,216.990877, and that's now in litres. So that's how much space is in those 4 tanks. We just now need to work out exactly how much space we actually need. So the fertiliser is to be mixed with water in the ratio 1 to 100. So the fertiliser to the water is 1 to 100. Karina has 32 litres of fertiliser. So she has 32 litres, so we need to multiply by 32, which means we're going to have 3,200 litres of water. And the total there, if we add those two together, is 3,232 litres. So, has Karina enough fertiliser for the 4 tanks? Well, it does say the 4 tanks are to be filled completely with the mixture, so they have to be completely full. Well, Karina has 3,232 litres, and space-wise, she has 3,216 litres. So she has more fertiliser than she needs to fill the tanks. Only a little bit extra, but that does mean, yes, she is going to be able to fill the tanks. So we would say yes, and you could write next to that, she will be able to fill the tanks. You can write any sort of explanation you want with it, because she has 3,232 litres and the tanks are only 3,216. So she is going to be able to fill them. And there we go. That was a functional volume question dealing with cylinders and having a little bit of ratios in there. Okay, so in this question we're looking at some frustums. Now a frustum is made by removing a small cone from a large cone, and that is actually what we're told in the start of this question as well. You can see that in the diagram. But it says here the frustum is made from glass, and the glass has a density of 2.5 grams per centimetre cubed. work out the mass of the frustum and give your answer to an appropriate degree of accuracy. That last line is quite interesting as well, an appropriate degree of accuracy. That means we sort of have an option of how we want to round it. So something like 1 decimal place maybe. So looking at this question then, can we get the volume of the frustum? Ultimately, it wants us to work out the mass. So we need to think about our density formula again. So we have density is equal to mass divided by volume. To get the mass, we need to do the density multiplied by the volume. We are given the density, so we'll just need to do 2.5 multiplied by whatever the volume is. So we'll leave that there and we'll come back to it. So getting the volume of this, I need to work out the volume of the frustum. We are given the volume of a cone formula, so I just need to work this out. To get the frustum, I need to get the volume of the large cone that used to exist before the top was sliced off it, and then we'll take away the small cone that was chopped off. So here we're going to do the large cone, and it's always good to label it, so I'll label it large and small. So that would be 1/3 times by pi. The radius here for the large cone would be half of 12, so that's 6. So times 6 squared. And the height of that large cone would have been 15. So there we go. I'll type that into the calculator. 1/3 times by pi times by 6 squared times by 15. And I'm going to leave this in terms of pi, because if I start writing down lots of decimals, there's a lot to write down, and as it's come out in terms of pi, it's much easier for me to leave it like that. So 180 pi. I'm now going to look at the small cone, the one that's been chopped off the top. But the small cone does take a little bit more thought process. Now we can see the total was 15 and this little height is 10. So the height of the little cone is relatively nice to find. That's got a height of 5. Now finding the radius of that cone, we need to think about what proportion of the large cone has actually been taken off there. And it's 5 out of 15. So this little cone, looking at the height, is 5 out of 15. And that is equal to 1/3. So it's 1/3 of the size in terms of proportion. So we're going to have 1/3 of the radius. So 6 divided by 3 to find a third gives us a radius of 2. So now we can find the small cone. So it's 1/3 times pi. The radius is 2, so times 2 squared times the height of the small cone, which is 5. Again, I'm just going to type that into the calculator. I've already got my old calculations there, so I'm just going to delete the 6, change it for a 2, and then delete the 15 and turn it into a 5. And there you go. It doesn't give us as nice a number writing in terms of pi. It gives us 20/3 pi, but that's still easier to write down than the 20.94395,102 that I'd have to write down otherwise. So there we go. That is the small cone. So to find the volume of the frustum, which is the whole goal here, because then we just have to times it by 2.5, I just need to do the 180 pi, the large cone, take away this 20/3 pi, which is the small cone, and if we work that out, 180 pi, subtract the smaller one, we get 520/3 pi. You could at this point write it as a decimal if you want. The decimal is quite a large one. It's 544.5427266. I'm going to have to write that again because I've got to now times it by 2.5. So I'm just going to stick with using this 520/3 pi. Just feel like that's easier to write down. So 520/3 pi that we're going to times by 2.5, as that was our density, and we're doing density times volume. So times by 2.5, and that comes out as now a final answer. Now it does come out in terms of pi. However, it says to give your answer as a suitable degree of accuracy. So I'm going to write it now definitely down as the decimal version. So we get 1361.356817. Now, a suitable degree of accuracy means we're likely not going to give that to 5 decimal places. So it would be absolutely fine to sort of round this to, well, we could round it to 1,361. That would be suitable. You could have 0.4 at the end. You could even round it to 1,360 and have it to the nearest 10. It's actually fine for us to round it in lots of different ways. But there we go. I'm going to leave it as 1361. that was of course a mass, and we were dealing with grams, so that's 1,361 grams. But again, I think you'd be allowed anything between 1,360 and 1,362, you know, in terms of how you've rounded it. So there we go, 1,361 is our final answer. Now our next question is looking at a circle theorem. It says here ABDE is a cyclic quadrilateral. Well, great, because opposite angles in a cyclic quadrilateral add up to 180. ABC and EDC are straight lines. That's helpful because straight away we can see what this angle next to the 60 is, because that makes a straight line. It says given that the size of EAB to the size of BCD is 2 to 1, work out the size of BCD. And you must show your working. Right, let's just find this angle on the straight line, then I'm going to come back to that ratio. So this one on the straight line here, they've got to add up to 180, so that is 120 degrees. Right, let's go back to this ratio. EAB to BCD is 2 to 1. Let's highlight those. So EAB is up here, and BCD is over here. Now, if they are in the ratio 2 to 1, I would normally label that either using algebra or keep it as a ratio. I'm going to label it as algebra. I'm going to call it 2x and 1x, just so I remember I've dealt with that. Now let's see if there are any other angles that we can find. So straight away, opposite this 120, opposite angles in a cyclic quadrilateral add up to 180, so that would be 60 degrees. Now I've got to figure out where to go from here. So we have a large triangle. If we have a look, I'll highlight this large triangle here, and we know angles in a triangle add up to 180 degrees. So now that we've written those two angles in terms of algebra, we can actually form an equation. We have 2x plus 1x plus the 60, and we know that all of those combined have to equal 180 degrees. If we simplify that, we get 3x plus 60 is equal to 180. We can then take away 60 from both sides, so 3x is equal to 120, and then we can divide by 3, so 1x is equal to 40. So now we know that x is equal to 40, we can actually substitute that into the two angles. This one over here would be 40, and this one up here would be 80. And from there we can actually go ahead and work out some of the other angles as well, but this question says to work out the size of angle BCD, which was this one over here, where the 40 is, so our final answer is 40, and there we go, actually we've written that down here, so we'll just keep that 40 there as our final answer. And there we go, there was looking at some circle theorems, that one only focusing really on cyclic quadrilateral and the opposite angles being 180. Of course, there's lots of circle theorems that you need to look at, so I'll link the video in the description for this one for all the different types of circle theorems. Okay, so moving on to some vector proof. This one here says the diagram shows triangle ABC. A to B is 3A, A to C is 2B, which we can see, and B to E is 3 lots of A to C. Well, that's actually not labelled on the diagram, so we could put that on straight away. That's B to E, 3 lots of A to C. A to C is 2B, so that would be 6B. And there we go, that's 3 lots of A to C. It says D is the point on BC, such that B to D and D to C is 3 to 1. So that is out of 4 parts, so that is 3/4 and 1/4. So that's how far along the line it is. It says prove that ADE is a straight line. Now these questions where it's asking you to prove that something is a straight line, I would say are some of the nicer versions of these questions. So this is a relatively nice vector. We're going to have a look at proving that that is a straight line. But of course, as always, I will link in the description a video for some much harder vectors. It's still a difficult question, but it's not the worst of the vector questions that we could have. So here we go, prove that ADE is a straight line. Now whenever we are proving a straight line, I like to find the vector for the full line to start with. So to get from A to E, we could go up by 3A and across by 6B. And that's going to give us a vector straight away. So A to E would be the vector 3A plus 6B. Now, whenever we are looking at these vectors, and particularly when we are looking at proving that something is a straight line, we want to actually factorise that vector. So we can take 3 out, so it's 3 lots of A plus, and then it would be 2b. So when we're looking at a straight line, we want to find another vector that also has this a plus 2b. So that's what we're going to be looking for. We just need to decide which one we're actually looking. So in terms of which one to look at, we can pick one of two separate lines now. We can either look at this line here, and to complete that particular line, there's a couple of ways that we could go about that. We could go up the line here and across. That would be one way, or of course we could go down and all the way around the shape. Now the other line that we could have a look at is this one here. And to move along that vector, the direction that we would want to go is up 3a and down here. Or of course we could go across 2b and up from c to b. Now it doesn't matter which way you choose, as long as we make the first decision as to which way we're going to go down that line that has no vector on it, so from b to c. So if I want to find the vector b to c, and that means we're moving from b to c, so I will have to follow this direction that I've started to go in, that I've highlighted. To get from b to c, I have to go from b to a, which is minus 3a, and then a to c, so plus 2b. And you can write that the other way around if you prefer, not to have as many symbols, but I'm going to leave it like that for the moment. So to get from B to D, which is 3/4 of the way down the line, if we had have decided to go C to B, the other direction, I'd only be going 1/4 of the way up the line. So it does matter which direction we're going in. So B to D is 3/4 of this minus 3a plus 2b. If we expand this bracket, we're just going to multiply the numerator by the numbers or the coefficients of a and b here. So we get minus 9 over 4a, just timesing that 3 by 3, plus, and then it'll be 6 over 4b. Now I don't need to simplify these fractions or try and be fancy with it at the moment. I just want to write the vector down, and I've got my vector b to d. Now I can get from b to d, I can get from a to d. So from a to d, all I need to do is add in that additional vector, that's a to d, 3a. So that additional vector here, 3a, allows me to get up to b, and now I already know the vector b to d. So for that one, I want to do 3a, and then I'm going to do minus 3/4a, this is just the vector above, plus 6/4 b. Now we are doing this with a calculator, so I can just do 3, take away 9/4, I can do that on the calculator, and that comes out as positive 3/4. So I get 3/4a plus 6/4 b. Now this vector here is the vector a to d, and somehow that needs to match the vector that we found over there, a to e. So a good job that we didn't try and simplify these fractions, because you can see quite clearly that both of these divide by 3/4, and that means we can factorise it. So that will be equal to 3/4 on the outside, brackets, that fits into 3/4 once, so 1a, and it fits into 6/4 twice, so 2b. And you can see straight away now we have that matching vector. So in terms of what we've got, we know that these vectors are parallel as they go in the same direction. So that a plus 2b signifies the direction that they are going in. And they both have that point D in common. They both go through point D. One of them goes from A to D, so it goes through point D, and the other one is A to E. So it's going through that point D there, so it must be a straight line. So there we go, that is our proof. We could write something like that, sort of linking these up and saying that they share a common multiple, or they share the same direction, and they share point D, so therefore they must be parallel and therefore must be the same straight line. Now we can as well have a look at the other part of the line. We didn't necessarily have to do A to D. We could have done as well D to E. So D to E, in terms of doing that, it would be a little bit awkward in terms of the direction that we happen to have used here, because we would probably want to now continue using B to C. So we'd do 1/4 of B to C, which would get us from D to C. Then we would minus 2b, then add 3a, and then add 6b, and that would move us all the way around. Obviously it would be easier just to reverse that vector and go 3/4 from D to B, and then 6b across. So we could do that as well, but obviously there's a lot of working out for each particular vector. So this is what we're looking for. We are looking for the two vectors having the same direction in their bracket and there being a shared point when we are looking for proving if something is a straight line. But as I already said, there are so many different vector equations, particularly the ones that are involving ratios and unknown quantities. So I will link the videos for vectors in the description for the timestamp next to this particular topic. But there we go, that was a question on vector proof. Now for plans and elevations, this particular one is asking us to draw a side elevation, and that's from the direction of the arrow. So this shows the front elevation and it shows the plan. So the plan is from above and the front is from one of those directions. Now you can kind of, and you don't need to draw this, but you can kind of imagine what this shape looks like. Obviously I I'm okay at drawing this. I wouldn't necessarily expect people to draw this diagram, but it can help just to sort of visualize it in terms of what it looks like, and it's almost like a staircase. So that's what this particular shape is. It's not asking us to draw a sketch of it, but you can see now from the plan, you can see this sort of part where there's 4 there, which is on the top here. We've got this next part, which is just there, and then this little step is this bit here. So that's what we can kind of see from above. Now, that makes it a lot easier when you can sketch it, but you don't need to sketch it, because if we are going to draw a side elevation, we know from the side it's going to be the same height as the front elevation. So I can actually just draw in the height, making sure it matches the front elevation. Now we can see here from this particular side that we're looking at it, that is this particular length just there. And you can see that's 2 squares along. So from the side, we would see those 2 squares, and then it would just be a rectangle. So it's the same height as the front elevation. We've got our rectangle drawn. The only thing that I need to add in to my side elevation here is every time there's a little change of height, we just need to add in an extra line at those 2 points. So I would add in an extra line here and also an extra line there. And there we go, that is our side elevation. So it does help drawing those just next to a front elevation. It does really help if you can visualise these. I wouldn't expect everyone to necessarily be able to visualise them and just draw a sketch just like that. Particularly with this one, it's a relatively complex shape. But there we go, there is a question on plans and elevations. Okay, so looking at some spheres and cones. Now we are given the formulas for these, but the questions, particularly ones like this where we have a compound shape, where we have a sort of hemisphere and a cone put together, we need to think through this question very carefully. So it says the total volume of T is 120 pi. The total height of T is y centimetres, and the rest of the information is given to us on the diagram. It says calculate the value of y for this one, so we're trying to work out the height of the overall shape, and it does tell us that we're going to be given our answer to 3 significant figures, which does give us a nice hint there that the answer is going to be a decimal. So as we work through this, let's see what we actually can work out. As we're given the formulas, we can work out the volume of the hemisphere. We are given that the diameter here is 7, so the radius will be equal to half of that, which is 3.5. Now we can substitute that into our volume of a sphere formula. Obviously taking into account it is a hemisphere, so we'll want to times that by a half. So a half multiplied by the formula, 4/3 times pi times 3.5, and that is cubed. So you can type that into your calculator. That comes out as 343 over 12 pi. You can write down the decimal if you prefer, but I quite like to leave it in terms of pi, as it means I don't have to write out a big long decimal and I don't have to worry about any rounding errors. That is the volume of the hemisphere. Now we were told the volume of the overall shape here, so this one was 120 pi. So we can do 120 pi and we can take away that previous answer, which is 343 over 12 pi. So you can see obviously in that step, writing it in terms of pi has saved us some time because we don't have to retype it in, although of course you can use your answer button on your calculator and just keep working through. Now that comes out as 1097 over 12 pi. Again, you can write down the decimal if you prefer. So we've worked out now what the volume of the cone is, as that's what's left. So we have the overall shape, subtract the hemisphere, and we're left with that volume of the cone. Now again, we are given the formula for the volume of a cone. And now we have the answer. So we could do 1/3 times pi times by the radius squared, so 3.5 squared, multiplied by the height, and that is equal to this new answer we've just worked out, 1097 over 12 pi. So now we have a sort of reverse formula, as we have the volume, but we are missing the height of the cone. Now you can type in all of these bits on the left, so 1/3 times pi times 3.5 squared, and then we could divide that to the other side. Now it looks a little strange if you write it as a division in the first place, because we would have kind of a fraction on top of a fraction, which always looks very strange. But essentially we're doing this 1097 over 12 pi, and we're going to divide that by all of those bits on the left hand side. So 1/3 times pi times 3.5 squared. That obviously looks very strange. It's fine to type it into your calculator like that. Of course, you could use the answer button, so it would say answer divided by, and then 1/3 times pi times 3.5 squared. But that comes out as 22.38775551. So that there is the height of the cone. Now this particular question, of course, is only asking us for the height of the overall shape. So we have up to the height of the hemisphere there, which is this 22 point, I guess we could write 387 up here just for the sake of being able to see it, 22.387. And we have the height of the hemisphere because that's the same as the radius, so that is 3.5. Obviously the radius there goes from the centre, in the centre of this hemisphere, down to the bottom, so that bit there is also 3.5. So if we add 3.5 to our answer, we get 25.887, and I'm going to stop there because it does say to give your answer to 3 significant figures, so we'll chop it there after the 8, and that gives us 25.9 centimetres as our final answer. So there's quite a lot of steps in these questions. They are always very different, but the really key part here is just being confident enough to use the formulas. Putting them in, finding any missing things along the way, and obviously this also involved doing one of the formulas in reverse. Now there is a part B to this, and it says the diameter of the base of the cone and the diameter of the hemisphere are both increased by the same amount. So it stays the same, it just sort of gets a little wider. It says assuming the total volume does not change, explain how it would affect your answer to part A. Well, this is quite an interesting one. So if we were to stretch the sort of width of this shape, but the volume was to stay the same, while the height would have to get smaller. So it would become, and obviously I'm not going to be able to draw this perfectly, but if we imagine it got a lot wider, well, in order for the volume to stay the same, because that would increase the volume quite significantly, the actual cone itself would have to get a bit smaller. So obviously just a little sketch or an idea there behind how it would look. But of course, for the volume to stay the same, if we're going to make that radius, that diameter, much wider, then the height would have to decrease. So you could write any sort of language there. I'm not going to write an answer down. You could use your own language to explain that, but it's just thinking about the concept of a question and what they're being asked. Now specifically here, they are saying explain the effect this would have on your answer. So I want to kind of comment on my answer. Now my answer was about the height, so I would say my answer would be smaller, y would be smaller, the height would decrease. But I'm referring to my answer in part A there. So there we go, that was some spheres and cones. Okay, so looking at a Venn diagram. Now here we have the universal set, and it says the numbers 1 through to 10. So they are the only numbers that we're allowed to put in the Venn diagram, and all of those numbers have to go somewhere in the Venn diagram, whether it's in A, B, the intersection, or around the outside. So it says in A we're going to have odd numbers, and in B we're going to have square numbers. So if we write down the odd numbers that are in the list there, we have 1, 3, 5, 7, and 9. And the square numbers within the list, we have 1, which is 1 times 1, 2 times 2 is 4, and 3 times 3 is 9. So there we go, they are the square numbers that are within that list, of course. 4 squared is 16, so it's outside the list, so just the 1, the 4, and the 9. Now the first thing we want to do is have a look if there's anything in both. So we have a 1 and we have a 9. So they're going to go in the intersection. Now as soon as I put them in the Venn diagram, I'm going to cross them off my list. I then have 4 that goes in B, and we'll cross that off. And I have 3, 5 and 7 that go in A. So 3, 5 and 7. So you can see there we have some remaining numbers. We have 2, we have 8 and we have 10. And let's cross those off. 2, 8 and 10. And you can see there I didn't cross off the 6, so I've got 6 as well. So always make sure you cross them off just to make sure you don't miss a number. Now I've got a couple of questions about this. So the first one, it says a number is chosen at random from the universal set. So out of all of these 10 numbers, find the probability that it's in set A, N, B, and that little n stands for the intersection. So when looking at the intersection, we're looking at the numbers here that are just in this crossover part called the intersection. So there are 2 numbers, so we would write this as a fraction and just say how many it's out of. So count up how many there are. There should be 10. This is a good opportunity now to count to make sure we do have 10. So 1, 2, 3, 4 on the outside, 5, 6, 7, 8, 9 and 10. So 2 out of 10, you don't need to simplify that. You can if you want, but just make sure you don't simplify it incorrectly. You could also be asked about the union. So instead of an n, you'd have a u. If it refers to the union, it's looking at all the numbers in the middle and in A and B alone. Okay, so part B here, or part C now, it says find the probability this number is in set B dash. Now the little dash there means not in B. So not in B means it can't be, and let's use a different colour here, it can't be 4, because that's in B, and it can't be 1 and 9. Even though they are in A, they are also in B. So not in B means it can't be either of those positions. So in terms of the numbers it can be these 3 here, and it can be these 4 here. So 3 plus 4, that gives us 7, and again that's out of 10. So there we go, that is looking at Venn diagrams and also some set theory. Okay, and on to some probability equations. There's lots of different variations of this question, and I will link a video in the description so you can check out some different variations. But this one here says that there are n red sweets in a bag and 8 yellow sweets in a bag. It says one of the sweets is going to be taken from the bag, eaten, and then a second sweet is going to be taken. Given the probability that both sweets will be red is 3 out of 5, we need to work out the number of red sweets in the bag. So of course we have this unknown amount, and when we're working out probabilities like this, we tend to use a probability tree. So if we were to visualise what the tree would look like, we have a red or a yellow, and then we're going to have a second pick where there is going to be a red or a yellow. Now in this particular question, we're only concerned about one of those roots, red and red. And rather than drawing out a whole tree here, because we're going to have some algebraic probabilities, it's better that we just think about the route that we actually want to take. So if we have n red sweets and 8 yellow sweets, in total, that is n plus 8. So our probabilities to start with will be out of n plus 8. So here we have red being n, so it's n out of n plus 8. If one of those red sweets is taken, then the numerator will go to n minus 1, and the denominator will go to n plus 7, as we've taken away 1 from the denominator as well as the numerator. Now to work out that probability, we would multiply those two together. So we would have n over n plus 8 multiplied by n minus 1 over n plus 7, and it tells us that that's equal to 3 over 5. So now we have essentially an algebraic fraction problem to solve. So we need to multiply the numerators and multiply those denominators. Now if we do that, the numerators, n minus 1 times n, would become n squared minus n. And the denominator there is a double bracket, n plus 8 times n plus 7. Now you can write that out as a full double bracket. It gives us n squared plus 7n and 8n together makes 15n. And then 7 times 8 is 56. And again, that's equal to 3 over 5. From here, we would need to cross multiply these denominators to turn this into a nice straight line equation that we can solve. So 5 lots of n squared minus n gives us 5n squared minus 5n. And 3 lots of that denominator, n squared plus 15n plus 56, gives us 3n squared plus 45n plus, and then 56 times 3 is 168. So we now have a quadratic equation to solve, and we need to make that equal to 0. So we need to move all those pieces on the right over to the left. So subtracting 3n squared from both sides gives us 2n squared. Subtracting 45n gives us minus 50n. And then minus the 168. And that's equal to 0. Now from here, you could use the quadratic formula, or we can have a look to factorise. It should be a whole number that we get, so we should be able to factorise this. If we divide both sides by 2 to make it easier to factorise, we get n squared minus 25n minus 84, which is equal to 0. And then we just need to figure out what numbers are going to go into our brackets here. So we want the factor pairs of 84. So for 84, we could have 1 and 84, 2 and 42. And as we go through, let's just think about whether we can make 25. We can't yet. 3 goes into 84. 84 divided by 3 is 28. And we can make 25 using 3 and 28. So we want to make negative 25, so minus 28, add 3. And there we go, that would make negative 25, that's equal to 0. So we get 2 solutions here, n is equal to 28, and n is equal to negative 3. Now in this scenario, where n is a real life thing, we can't have negative 3 red sweets. So our solution has to default to this positive value. So the answer here, n is equal to 28, and that is the number of sweets in the bag. And there we go, that is working with a probability equation.